Aha, dobra. Dzień dobry, witam wszystkich. Wybiła 9:30. Kolejny dzień. Pierwsza sesja. Witamy pana tłumacza. Jest na styk, ale nie pośpieszamy. Szanowni Państwo, pięć prezentacji, 5 referatów. Zrównoważony rozwój na terenach pogórniczych. Ważne kwestie dzisiaj od rana. Witam wszystkich uczestników. Na początek KGHM Kuprum, pani Anna Jakubcewicz i pan Kajetan Witecki. Zrównoważony rozwój, czyli aspekty środowiskowe, technologiczne, ekonomiczne w inżynierii mineralnej. Zapraszam. I chyba dodatkowa pani jeszcze jest, ale...
Dzień dobry Państwu, dziękuję bardzo serdecznie za przedstawienie. Wraz z moją koleżanką Izabelą Kruszwicką z Zakładu Inżynierii Procesowej KGHM Kuprum. Bardzo miło nam jest rozpocząć sesję zrównoważony na rozwój na terenach pogórniczych. Naszym tematem
in environmental aspects, technological and economical and mineral engineering. So the aspects, economical aspects in the mineral engineering. So for many years, we are the biggest producers of the silver and cuprum and copper. It's not just only the mineral resources, but also the very high responsibility for the sustainable management of the resources. And the question is, how can we minimize the negative impact and at the same time with production of the minerals? In the scale of the world, the sustainable development, we should be responsible in 3 areas: economical, environmental, and social. So our goal is harmonizing all of these areas, and in order to start the concept of the technological progress, take into account the economical and social, and decreasing the negative impact on the environment. So this is the yearly production. So the natural resources that are not a renewable materials, the production of the wastes make so it impacts the environment in a negative way. So that's why we're having quite a lot of challenges in the light of the idea of sustainable development. And then, of course, meeting the more and more stringent environmental legislation, we have different initiatives, political initiatives into the environmental protection, like the Green Deal and the European Green Deal. And the strategy of many companies. We've got the plans and strategies concerned with integrated development. The same is for and then in effectiveness and ecology and safety of this sustainable development and the synergies. The energy, that is why, because mineral industry plays an important role in the energy transformation. Also, it is involved in all the projects connected with the green energy. One of the very important project is the PV farm, Elvira. It's in Chile, Atacama, Codelco. It produces 54 megawatt hours of electricity. That's why it's 85% of the consumption. And it limits also the production of CO2. So this is economical with environmental issues. All of them were met and the goals. One of the more important strategies of Polish copper is the decrease of the greenhouse gases emission and the renewable sources of energy. We've got it in the more green energy for the KGHM Zanam in Legnica. It's a PV farm. It's 50% of the demand for electricity. And we've got also the further works. Like this year, for example, we had a project approved, the PV project for the furnace, copper furnace, and the energy transformation is the 50% of demand, as was said. Then the green energy, but we can also have the green technologies, which is implemented in the projects. But before we have those projects, let me remind what is the process. And this process of the bio-leaching and they transform the non-organic minerals to energy. The substances are dissolved and could be recovered. So one of the projects is the project in BioShale. It's an innovative cooperation of the so-called black shale with the biotechnology. In the project, we've got the reactors and the columns, bioreactors, and three beds. And the result of this project, the main result, was a recovery up to 98% of the copper. And this concept was a very good solution because there's quite a lot of composites or compositions which are difficult to extract by the traditional methods. The next project, BioMore. So this is just searching for the metals from the deep deposits with the biotechnologies. there was an implementation of the production of metals and excavation of metals without building an underground infrastructure. So we had this advantage that we didn't have to produce or mine the metals and the ores. It limited the storing of the metals on the surface. So it's a biomar concept, an alternative mining concept. In the light of the waste being with weights, in 22, 150,000 of tons of waste were created, and they were as byproducts of enriching of the flotation, enrichment of the non-metallic, non-ferritic metals. So this is just a character and technological right now present on from the 30 million tons of the product, and then we've got 80 million tons which is stored in the Żelazny Most. One of the strategy pilot is the building and developing of this object with the next parts. But even if we don't think about the safe deposits, we would like, there is a goal to have such solution with a closed circuit, closed loop, in order to change them, transform them to the products, market products. That is why we've got a float book with a consortium of the Ceramic Institute in Opole and KGHM Kuprobo. We are elaborating the technology and also the very fine fraction materials for enrichment of the ores, KGHM Polska-Miedź. This project is in the third phase right now, feasibility study, and we are working on the analysis, economical analysis and environmental analysis. Even today we can make we know already some questions, economical, technological, process and environmental. There are the huge potential in the solution. So economically, we've got new products introduced to the market. We elaborated also the material that could play the role of the mineral adhesive, or it could be one of the contents of the formulation to production of the autoclaved concrete, which is a new and modern solution on the civil using the waste within this scope. And then we could also have the project by decreasing of the costs, operational costs, those costs could be then spent on transportation or depositing of the waste, processed waste. So then technologically, it's a huge input in the development of the science and technology of processing of the waste. Post-mining process is an innovative product meeting the standards, the discipline standards, the industrial standards. Then environmentally, this is just the processing of 1 million of tons of waste, flotation waste, and then in the future even more. In this project, the material is changing for a very useful mineral product. the future. And the projects that we are having right now, they are the big input to the future solutions on the sustainable development. It is also possible to find such a balance for technology, economy, and environment. Thank you very much for listening to us. Thank you very much for presentation and that you are on time. Did you have any questions? Do you have any questions? I'm terribly sorry I did not introduce in the beginning. From my side, I remember 12 years ago when I was in Finland, Gdynia, Kopień, so we saw this installation, the full-scale productive, and then it was a new thing of nickel. Today, they produce 100% by this of their possibilities, and very interesting technology, but I don't think it's not that easy to be used for different reasons. I think we'll discuss about it later on. If we don't have any questions, then if Mr. Marcin Marczak is present, presentation is so the natural methodology of the so we're having it here. Carb farming.
Dzień dobry, witam serdecznie wszystkich. Ja reprezentuję spółkę Carborating i jedną z naszych inicjatyw jest carbo farming. A dzisiaj porozmawiamy sobie trochę o
So talking about the hemps and why they are important for the point of view of
tej branży, czyli
this discipline, this industry, mining,
jak można tak naprawdę
and how can we, by the natural methods of the hemps,
rośliny włókniste, ale nie tylko,
but not only microorganisms as well,
naturalną symbiozę,
how can we restore the natural symbiosis,
też jednocześnie jeden bardzo ważny element, jak zarobić na tym.
and also how to make money on that.
Jeśli chodzi o nasz zespół, to składamy się z głównie ludzi, którzy
So we are the people
działają
who
w obszarze bankowości i finansów.
are working in banking and finance, biotechnology and farming,
W naszym zespole
agriculture. So one of the partners was the founder of the mission.
od 15 lat
Me, for 15 years, I'm responsible for biotechnology, biorefineries, and the sustainable economy. And we're also having
doradców z zakresu
a dozen or so advisors for agriculture or industrial agriculture that for 5-6 years they focused in hemps mainly. So we're talking about the hemps. Most of you think marijuana. No, this is unfortunate. So these are the, so we will not discuss about it, but the hemps. This is a result, industrial. This is one of the main industrial mineral or used in Polish economy. For the hemps, of course, first question is if they are psychoactive. No, we don't have any high there. We don't have THC, but what we have here, a lot of resource, that means a lot of money. So in this case, for the industrial hemps, will not be responsible for the psychoactive substances, but will have the possibility of the very big income, mainly due to the plenty of the use, but also the fact that this is a fiber plant, and the natural fibers are expensive because the fibers, it's actually this is the same what the fiberglass. So in the turbines, sometimes we've got a tendencies instead of the fiberglass to use the hemp fibers or mainly the linen, because for the fibers and vibrations, linen is much better with the same strength. So we will have this is a product that is expensive and generates a huge return from a hectare. This is important because we're talking about cultivation and we're having we don't want to spend a lot of money, we would like to earn. So the hems, they have 10,000 industrial use. We can have everything could be the concrete, fibers, composites, soap, and quite a lot of detergents and different things. So it's unlimited use, and they could enter every single line of economy. So as we know exactly if this is recultivation or restoring, this agricultural cannot be eaten by people or animals, but if it's in the concrete, then yes. So if we have the industrial hems, 16 tons of high energy biomass that could be also used, we're able to generate a huge return rate on the level of more than 10 or so from the hectare in up till 80s, the canopies and linen, so the fiber plants were the base of Polish economy. This was the second product. So it was coal and then the fiber plants, textiles and some other products. So then we can see the potential and the value of the material. Because with our approach that we're using for the phytoremediation is also concerned and connected with the income. So once we can see post-industrial or polluted, so it's an easier solution not to reinvent the wheel, but we could use the plants. They grow itself and with a lot of properties that we're saying about the oily. So they are used also for the industry, for the uranium mines recultivation. So we've got a lot of applications. We've got publications for that where it could be used. So in Poland, in Silesia and lower and upper Silesia, we used to have the textile fibers and textile basins. The lower Silesia, we had a lot of linen and hems, plus the eastern wall, Hrubieszów in the eastern Poland. They were the main parts. When you discuss with these people there, as long as they were the industries and the factories, the welfare was there. This was a very good element because it could generate huge incomes and profits. When you see the potential for Silesia, so for the bioenergy and fibers, we will have billions, a couple of billions of zlotys for the country, it's of course more than 10. And important, and we're talking about billions. So for the important things is the fact that we can earn 3 times. Why 3 times? First of all, we can have the grant with quite a lot of financial means. So we'll have. So this is the income. Then we've got the credits, the coal credits. If we can see the hems, nothing has got. When we can see the line, and then they've got a very deep root system. Thanks to this fact, they crush and they powder everything which is inside, even if there's stones inside. Then plus, there is a source that has 16 tons out of hectare. This is 4 meters high. During one season, vegetation season, there's a lot of energy that it could be used in the waste incinerators, but not only. It could be used also in ferrolysis. So the biocoal, if we return it to the field, is a very high-class fertilizer. So that's why using this equipment plus the root system, which is very deep in the and sequestrates a lot of. It gives the humus to. So that is why the coal, after 3-4 years, they can decompose it to the fertilizer, and then we can use this and use it as a. So and then we can sell it because there is a lot of humus there. So we've got a couple of sources of income, and mainly, the ones that I knew, it was investment. It was not. So here, we're using the natural methods, we can reverse this process. That means we can make money on recultivation. With regards to the methodology itself, the HEMS is not enough because all the plants, they need them microorganisms because they communicate with the soil, with the microorganism, fungi. So these are the intermediaries. The information is given to the bacteria and the fungi, and then they are. So in our model, we have the oily, the fibers. First of all, the product that we make money on, then we use the microorganism to build the humus, and then we've got the activating substances we add. So in that time, so also they activate the plants. They are the key in the process. Right now, we're starting with the pilot plants in the 3,000 hectares. This is important because we need the business to cooperate with a lot of to have it in the chain of deliveries, because first of all, we've got products in a small scale, technologies are there, but we need a big business to join. We need big, that we could have more than 50,000 hectares, and then it would be the plan for Silesia. Why? Because first of all, we want to enter the industrial zones, because this is the easiest thing and show the full potential. And then, once the companies and the big plants that can create the resources, but also the natural resources can be added, once it's in then we could have the industrial plant. So even if we are in the mass production of biologization, technical, and of course sequestration of CO2, so which is the subsidies for the production, for the reduction of emission. And this is going to be my next presentation, how we could use them in order to reduce, so that we're ready to generate 3 billions of zlotys. And these are we've got very low indicators here, with quite a lot of resource with a very low value, but when we add more and more, we can then prepare it for textiles. And then the natural concrete with a higher value, so then in the most optimistic we can multiply every hectare by 30,000. And this is the added value. Of course, if we do it times all the voivodeships and the regions, we can see how much money we can earn, starting from the phytoremediation and purification of the areas that were polluted by the industry. And we've got 3 things as a result. First of all, in 5-6 years, it could be then started to the full farming and agriculture after 6 years of HEMS, then earn a lot of money. In the meantime, then we could have a very good product. And then we can have, or we can limit our carbon print. So implementing those projects, we could add this sequestration print as our own de-emission, and then our industry will be very green, and the HEMS are green. Thank you very much for your attention. That would be all for the natural reclamation. So if you would like to know more and more details, please, of course, I'll be here for the whole day. And I would like to invite you for contacts if you're interested, if you could start such a project of the phyto reclamation. Thank you very much. Very interesting presentation. We will listen about the core credits. Do you have any questions? And very interesting presentation of the reclamation by HEMS. It's an important thing which is also discussed during the yesterday's panel. It sounds really promising and encouraging. Where's the catch? But I think that we could discuss later on. If not, if you don't have any questions, then KOMAG, represented by Michał Zygmunt, the concept of the contactless reclamation of soil in the so-called recall. Thank you very much. Oh, got a problem with it. Oh, right. Thank you, Chairman. The concept of technology that I'll present to you, this is a fragment of the big project with the name Recall. Here we can see the KOMAG team. A couple of days of introduction. Generally to what is it about? The name is ecological reclaiming and a long-term monitoring of the post-mining areas. As it was said before, how important the reclamation is, that's what we did. Is being financed from this RPS project grants. So we start a research fund for coal and steel. It should last until December 2026. The budget is €3 million. I've got 11 partners in consortium from the EU. RICAL is implemented by the International Interdisciplinary Consortium, and we've got 7 research institutes, 3 partners, industry partners, and 1 innovative enterprise. We've got geologists, hydrologists, ecologists, microbiologists, engineers, biologists, miners, chemists, economics experts, and IT from 5 European countries. From Poland, we've got the coordinator it's the state Pol-Eco Open Pit Institute, and then the consortium is Central Mining Institute, then KOMAG and Polish Polska Grupa Górnicza, PGG, Polish Coal Group. We've got also people from France, Czech Republic, Greece, Slovenia. What was the reason behind the project is a degradation of the environment on a huge scale and the loss of the biodiversity by the historical and current activities in coal production, also the economical challenge in the coal, and also the unemployment. So we've got the societies of the local communities, self-governments all over Europe in the post-mining areas. Especially we have those problems once the coal industry is being decommissioned. And especially the climate neutrality until 2050, which requires stepping out from coal phase out. So it's the goal is the use of the knowledge of the post-mining areas with the take into account also reclamation and monitoring of ecosystem, future ways of use of, and the friendliness of the prices. So I've got the goal with 5 detailed goals, which is an assessment and cataloging of the knowledge and experience for the post-mining areas, and then elaboration of the new solutions for post-mining reclamation, cost analysis, then elaboration and test of the tools for a short and long-term monitoring of ecosystem reclamation, then innovative methodologies and methods of the ecosystems on post-mining systems, and also familiarizing of the stakeholders, the regions of the results. So in KOMAG Institute, we are responsible for the contactless reclamation of soil with the use of the bio-waste. We've got 3 main stages. First of all, we've got the reclamation responsible for enrichment, and so in this goal, in the selected fragment of reclaimed area, we'll have an active bed via the compost and bio-waste. Those mixtures on blends are elaborated with different than the project. Then the second stage, stabilization of the soil, but using the seeds, the mix of seeds with the adhesive. And the third stage, the parameters of the water content by water spraying. The concept is the use of the aerosols with the new solutions with special nozzles for transportation of the utility or the medium, So it's very similar to the known solutions of the hydroseeding or watering by the water guns or hydro guns, but it's all compacted in one device that will make quite a lot of activities at the same time. It will be supervised also by the system, photographic, and the water content monitoring by the NDVI. And so we will have the detectors installed in some areas and also the drones inspection. So how will it work? On a selected area, we'll have the inventory of this area. So we'll have the points for which we could have the equipment to be sent for the reclamation. And in each of those points, according to the information and analyzed, we will have the special procedure to be used of the land reclamation. So for such a photograph, by the multispectral NDVI will allow us the condition of the vegetation, and then we will have the proper procedures decided. In the points, we will have a special equipment for spraying the factors and so maybe we will exactly know what nutrients are necessary, water is necessary. So we'll have one of the stages of the reclamation will be undertaken. Here we have these are the ranges of the equipment, of the instruments, so we will know exactly one of those three stages will be used. So we'll have the spraying in a precise and selective way for each selected fragment of the reclaimed of the area being reclaimed. We'll have a controlled range for the selected fragments of the area that is reclaimed. So generally, that's what we think, basing on the information from the drone and the photographs analysis. We'll have the areas for which we will use the special sprays as per the procedure. So either more water or more fertilizer, a different mix, or additional seeding. In the project, we plan to have a test in the real situation of the equipment for a lower scale. Right now, we're elaborating such an additional instrument, so it will be 3 tanks that will be there, 1,000 meters each, and so we'll have water in one of them. Then we put a fertilizer in the other one, and the third we will have the seeds of the plants with an adhesive mix that will allow us to cover the reclaimed area and the soil. They will be connected to one collector and one header with a pump. So we'll have electro valves there, solenoid valves. one of those 3 tanks will be used. So the pump will have 100 liters a minute with a 0.3 bar, autonomous. Everything from the aggregate 4 kW. So we need such a power supply because we've got a mixers there on the tanks of the fertilizer, natural fertilizer, and also the mixer for the seed with the condensate. We need quite a lot of power installed. So the gun, the air gun, will be used with 2 nozzles, and depending on the means to be used. So we will have the selected gun to be used. Its angle will be by the actuator, electrical actuator, and it can also be, it can spin 360 degrees by the gear. So this solution is more nice, but much nicer. So this would could look like that will be then sent on a reclaimed out to the reclaimed area, and will be fully automized. So with all the detectors and sensors, plus additional information from the drones, analysis of the photographs, and the procedures, what should be done and when. We'll have a program of the implementation of the reclamation, and the equipment will be sent into the location, and then with a procedure it will work automatically. For each selected field we will have the procedure installed, and we'll have a panel, control panel by the tablet, and so we'll have to go there to the point and know exactly where we're going according to GPS. So we have the prototype already built. Then we can exactly know where are we. Is it an app? And determining of the distance from the base point. So that's what we plan to do, the test. So we then think that for our test it would be enough to have 60 to 40 meters of the reclaimed area. So then we'll have 8 fields, the small fields, when we could have the test. And one bigger field when we could have the procedure of reclamation according to the best standards, when we would like to test all the solutions that according to our and consortium partners would be optimal. Thank you very much for please come to recall, visit the recall site. We also have a roll-up for the recall when we have the QR codes. So if you could please like us in the social media. Thank you very much. So as you can see, this is from a very well thought system. Professor? You need to move the car. Maybe this is going to be, I'm looking at this proposal here, and nothing was said about the atmospheric wind, or if you have the area which is not flat, maybe some correction would be needed. Because the question is, how about the wind with the aerosols? Or then we'll think what we're going to do. Professor, you're right, because if we have wind there, it might go in a different direction. So the first test with different where it goes, the sprayed agent, and all those corrects. So we will check the wind direction, and probably the correction will be there. Must be, of course, yes. Any other questions? Thank you very much. So it's all system. So we get quite a lot of. So once more, Marcin Marczak, carbureting and carbon credits. It's not only that's all the sequestration of CO2 and generating of the profit, because they can come not only from the credits but also from any single. Why? Let's think about. So first of all, I would like to say more about carbureting. So we as a carbureting, as a team, we've got the experts from many partners, from many. So it's banking, finance, also methodologies, biotechnology, but also IT, and we're working with different tools of the AI, the ESG modeling, or just the benchmarking as well. So we are ESG, so that would mean from preparation of the report, CSID, that this is not important right now, and the strategy as well, but also the help, because as a matter of fact, for ESG is not just a one point, it's a process of transformation. Where are we now? Right now, it is not a very, we'll have the closed loop. So once we have everything used based on renewables, but it's a process. If we have the closed loop, then if we emit something, then it has to also absorb. So that's why when you can see the credits, coal credits, most probably you think about EU ETS and the emissions, but also there's always two directions here, because so it's EU ETS, it could be used also in the ETS.
do wyłapywania CO2
for the sequestration of CO2 or some different greenhouse gases or reduction of the greenhouse gases. And from this title you could have some significant profits as well, financial profits.
Drugim obszarem takim kredytów węglowych
Then the other area of the coal credits, which is not bound with ETS, these are the voluntary carbon credits, or VCCs, or the voluntary carbon markets. These are the carbon credits bought by the huge corporations from the USA. They could be in a Google when they want to show that they have zero carbon print. What they do, they emit, but also they buy the carbon credits for the emission. So if we see about the closed loop, the circular economy, it doesn't mean that we'll have that will not emit, but some of them will emit, but the other will absorb. This absorption could be also in within one industry or one factory, one enterprise. So if we have the sequestration projects and absorption of CO2, of the greenhouse gases, we could also create, first of all, the mechanism of balancing of the coal print, carbon print, but also limitation of the ETS. Or we can make money for our ETS. So we can create a carbon credit by its VCC and sell it to somebody else. And for the money earned, limit, for example, our own costs. For the voluntary credit, there's one problem here. It used to be a lot of frauds on the market, and UN said what was implemented mainly in the equator countries, there was the biggest disaster, cost billions of dollars or trillions of dollars by the UN. So most of the projects in the jungle had nothing to do with saving of the jungle, but somebody took money and then the forests were cut anyway with the money. So it was a mechanism that was present all the time. So many projects that we have right now, which are not documented with a full set of prepared reports and methodologies of all the partners, they are just worthless. But the projects that in a proper way are documented of the absorbed CO2, so they're called sequestration, and they are approved by the international gold standard, the huge organizations. Then there's VCCs, they can up to 50 euros, so they are very what we have on the EU on the ETS market. But for the forecast, we know that sometime it used to be $100. It was very close to more than $100 when the carbon credits were more expensive. And unfortunately, this is just the beginning. For different reasons, political, economical reasons, geopolitics is right now very wind up. But those carbon credits are go down right now. But all the show us that within a couple of 4 or 6 years, this value should excess 100, 200 euro, could be also 400 euro for 1 ton of ETS, so CO2 ton. So it's a coal of ton, it's 2 ETS, and a ton steel is 2.5 ETS. Then the EUA credit, carbon credit, then we can have that to every steel ton. You'll have to add up to 1,000 euro. So if we have to pay for that with no alternatives, then this resource will be not profitable anymore, and it would mean bankruptcy or insolvency at least, because you can increase the prices to a certain moment, but not endlessly. So for the carbon credits, first of all, the sequestration, absorption. So we need to see the project that absorbs. So the sequestration of CO2 methodology, which is approved by whom and why, and then reporting, which could be easy found is transparent by everybody, and we can see the real indicators that cannot be undermined for reduction of emissions. So if we have a very well designed project, and then we have in the VCC market, it could be the ETS, because you can then go to the methodology with the project of the sequestration of CO2 as the emissions in the industry. So if we have the VCC project, then it could be the ETS, it can remain, and then it changes the financial dynamics. We can hear a lot about the CO2 sequestrations, and then carbon sequestrations and very expensive installations. So we thought if there is a mechanism that already absorbs, captures CO2, and we have plants. Plants, they capture the CO2 and transform it into the biomass. So if we use this effect, then we could use the natural resources that we can have, concrete or some other composites, that for 50 years they can capture and sequestrate the captured CO2, and then we have exactly the same goal that could have been reached by the complicated installation to CO2 sequestration and capture. So the catalyzers of filters that could catch from the atmosphere is really difficult and requires a lot of energy there. So with our business, a simpler solution is just the use of the natural resource, so the natural systems, so the biomass. But with the use of the plants. So we could say that emissions, coal credits is just EU. This is not right, because as a matter of fact, it concerns the whole world, also Greenland, because Greenland is Denmark, and Denmark signed as well the Paris Agreement. What we have feed for 55 or Fit for 55 and also the emission product is nothing else like the implementation of the Paris Agreement. The EU is the first one, the other ones are waiting, because a lot of analysts, financial analysts from Wall Street, London, say, we will wait, let's wait for the EU. As long as China don't do it, it doesn't matter. But China started the ETS, and all the listed companies, they will have the reporting of the zero emissions, and they will require from everybody else. So India is the worst situation, and the US, because parts of California or New York, when they had their own emissions, not all of them they got the ETS, because they have the ETS on the level of the state, not the federal.
Różne, bo to jest średnia rynkowa, tak? Tak jak mówiłem kiedyś, ze względu na to, co się wydarzyło w projektach ONZ,
Due to the fact by the UN projects, the price of the credits, voluntary credit prices, fell down to the level of €3.7 or dollar, but until 2030 they should go out. If our project is prepared to the ETS, is during the certification, the full certification and the analysis with EU, or it's used to the agro ETS, then we could use this curve and sell the credits on the international market. So this is important from this perspective, that we have quite a lot of possibilities of earning, where we say about the carbon credits, VCs, and capturing of the CCS, of the carbon, if we come with the farming or agriculture. But we're going rather in a different direction. We just produce food, but if we have the industrial food industry, then we could, as a matter of fact, it's not only an increase of the natural resources, so we can have the process as the fillers or substitutes, but also use the fact that we have such a material, then it's worth also the CO2. But in order to use it, unfortunately, you can prepare the infrastructure, mainly the IT infrastructure, to document it in a proper way. We as a company, we are cooperating with many suppliers of different software, because we try to integrate for such a process, make it possible for the enterprises. So if you're interested, should be interested, please, if you could. Thank you very much for your attention. Thank you. Thank you very much. Second, very good. Thank you very much. Well, I'll talk you, unless you have questions right now. If not, I would like to ask the last one, Mr. Krzysztof Jastrząb, with the presentation of the hybrid system of the storage of energy with a post-mining infrastructure use. First of all, let me use the equipment. Most probably, you met already this word of the hybrid system of energy storage. Why am I using it? So this is the official slide of the EU. In 2022, there's a project that we started for the hybrid energy storage system. This project we started to implement last year. €2 million. I'm the coordinator as the Institute of the Fuels and Energy. As I said before, this project is being implemented in a consortium of 7 entities: the Institute of Fuels and Energy Technologies, also KOMAG, University of Silesia and Technical University of Silesia, Technical University of Ostrava, and Promogowy Ekwalencie do Slovenia company. We've got three. So we've got then the EU. 60% is from the research fund for steel and coal. Then we've got the domestic ministry, and our own means 4%. For the commercial, we don't have any, so it's 40% from the commercial partners. So what was the goal of the project and the aim of the project of the hybrid energy storage? Using the post-mining infrastructure, we decided to use it to create the energy storage that would be used by the green energy from the renewables. And in the infrastructure, we could store it in three ways. First of all, so we'll have the heat pump. This is the pumping storage energy. Then also the compressed gas one, CASS. And then the third one, this is the heat energy in the form of the thermal storages. They are very well known. Our partners taking part in the projects, they are responsible for the storage, but the thing is, it should be all combined in one goal. We've got one system controlled by the energy router, electrical router, and it's called connected with the grid, with the energy grid. So what were the assumptions of the project? We wanted to have, each of them will have 10 megawatts. Megawatt hours of the capacity, and altogether they can store 30 megawatt hours. So the concept, which is called the HAS, thermal energy storage, pumped storage, hydroelectricity, and compressed air energy storage. They are integrated electrically and mechanically. So I've got energy router software, which is a system that INC IT solution, also the control level, and then we've got electricity, of course, from the national power grid. So we split it in 7 stages. The second stage will have then the review of the networks and so on. Then 3 phases for 3 different stages of the energy storage, and then the last thing would be the last but one would be the router, and the last variant would be the techno-economical way to have a look if it's reasonable. Then about every stage. Stage 1, management and coordination, a lot of work, independent workflow, then identification infrastructure of most mining. So we'll have the selection of the mining shafts that could be checked if they are suitable for this use as the compressed air or gases to use and then we've got a selection of the corridors underground for the pumped hydro storage. So the underground waters, they should not be mixed with the, so they should be, we should have the energy from the pumped out water. The work package 3, so we'll have the Technical University of Silesia, then we put all the partners, we've got the identification of KOMAG and the Technical University of Silesia. We also have in Czech Republic, in Ostrava, and of course in Slovenia as well, where there is the industrial partner. This stage is right now being at its finish. I will not present the results. I will just present the project. Maybe during the next conferences I will present you the results. Then the third phase, these are the storage of the heat, pumped storage hydro plants, 2 tanks, upper and the lower reservoirs by the turbo set. So we'll have a pump out, and the leader is KOMAG Institute. My colleague responsible, Mr. Matusiak, who is responsible for that. This will be a classical set, just a pipe with a turbine and a pump. Then work package 4. This is this compressed gas. We've got two tasks. First of all is a storage with a compressed air, and the other is a storage with this compressed CO2. They are very similar. A shaft then is a tank. Of course, it has to be sealed, but in case of the storage from the compressed air, it's up to 80 bar. With the CO2, it's lower, and it's only 20 bars. Actually 5 bars. In both cases, there is a tank of the compressed gas. So that's why we know exactly 4.1. The manager of this stage is Technical University of Silesia. Of course, the other partners take part in that. Then work package 5, this is a storage of heat. With the feeders of the heat batteries, so it would be a leader. Also the Technical University of Silesia. They are very experienced in storage of the heat in the mineral deposit, and we also plan to have the use of the change phase material later on. Once testing those 3 stages in 3 different ways, in the 3rd stage we will have the hybridization of those 3 levels. We will see what's the interconnection, intertwining, electrically and mechanically connected. With the CO2, there's quite a lot of temperature, so we could use maybe the heat feeders there, and of course then We'll have the energy router, the control of everything. So we're talking about the singular system, hybrid, of a singular mining, but the to-be solution, this is going to be a grid cooperating, and how much can it be done? We can make it in all mines suitable for that. It's quite a lot of them. If all of them are suitable, we don't know. We'll see. And the last stage, we'll have the analysis. If it's profitable, how much money does it come? What will be the cost, and how will it impact the environment? So that's the project. I will not present any results today, but I think next year, during the next conferences, we will try to present it. Why are we doing it? Of course, this is we want to have it in the industry, industrial solution, and implementation application, to have a local storages, something which is very needed. We've got the PV panels, we've got the wind farms, we've got the surplus of production. Sometimes we've got the peaks and too much energy, sometimes we've got not enough deficits, and it would allow us for the rational management of the energy. Who will be the client? Of course, the Polish system operator and power stations, power plants, and energy companies, traders, also the local governments. We do hope that we will have so sometimes, and of course also the companies for connected with mining. So this is the company for the restructuring of mines, and the project is half a year ago. So they are presented into the project page. Right now this is, you can see where are we. Also in the European. So we also have the bulletin, the newsletter, and you can see it. So that would be all. Thank you very much. Thank you very much for the presentation. Do we have any questions? Yes, there is one. I want to say that really, when I have a look at the scope, that this is one of the most probable and reliable ways of solution of the problems of the, like, combining all those, especially PVs, when we have a surplus of energy, electricity that are not on the all level of the time, because sometimes we've got those waving. So we're talking about megawatt hours, and usually we're talking about kilowatt hours. So these are 3 times. So those systems, they give a lot of hope that significantly they can give us the balancing or making this demand more flat. I'm very interested in a pumped storage hydro plant because we need some insulation between the levels and so on. Not necessarily we need to have outside, because to 800 to 200 we can pump and then go down. Everything underground. And to recover the energy, like in Porąbka, for example. So I think that this, as you can see, it's quite new right now. There will be quite a lot of problems connected with geological law legislation, because physically it's quite simple, it's obvious. And there's quite a lot of experience there, but those systems, they are functioning all over the world. So I think in the Polish mining, of course we're talking about hard coal, because the other copper or some other cuprum minerals, not even the underground, because we can try to use them also in the open pit mines. We've got a different, that's all, just a comment. In my opinion, this is a reliable and probable success. A couple of years probably it will last, but it's not for tomorrow, it's also for the day after tomorrow. Thank you, Professor. I'm of the same opinion, but there's quite a lot of risks, yes. Then we have also, we have quite a lot of the stringent legislations there. It's quite a huge cost. I would like to draw attention to the fact that very often we've got a general then. So, you know, those corridors are with I'm most skeptical, but maybe I'm waiting for. But we need to know exactly. My name is Paweł Kamiński, and I'm responsible by KOMAG, and I led this session for you. Additional questions maybe we can find later on. Thank you very much. Thank you. And see you soon. (11:15) So thank you very much that I can present it for you. Then I could say that this is just a general presentation of what could be subjectively most important in the circular economy resources processing. What I would like to show you, there are really huge, quite a lot of achievements there, and they are very promising for the future. So we'll have the model, the circular economy that all of us know. Then the circular economy, the most important thing we design everything, all technologies and everything in such a way that they could be later on utilized or recycled. This is the first thing and the most thing. So we can't have such batteries without changing the batteries or the refrigerators that we cannot repair. And then increase of the last thing. If you are from Krakow, then we do not throw away anything. Everything that could be used, we try to use it again. And if not, then we can at least dismantle it and to reuse it somehow. If we can't do with the equipment, then we need to recycle it. And this is what we do here in the AGH, also the research institutes. This is a huge knowledge behind, dedicated to this fact, to do something with the equipment which lifetime expired. Circular economy, the closed loop. So this is a circular gap report, and the circular Poland is circular in 10.2%. So each 100 kilograms, 10 kilograms of the materials is reused. 90 kilograms are, and then we use the primary resources. 613 tons of materials we use, which gives us 1570 tons. These are the primary. So ores, energy, rock minerals. And 100 tons, these are the recycled or recovered materials. 13 is 14 tons a person. So it's 25 tons in Sweden even per person. Then how about the world? Poland, it's 0.5% of the number of people, and we're responsible for 0.6 material print. Then when we use that could be regenerated, it was 28th of July. So that would mean that we should have 2 globes to secure our needs. So what we do, yesterday we had President Radek, and today as well. on this sustainable development in the capital group. This is a huge impact, 32 million tons, mainly the waste and the byproducts, because these are the characteristics of the ore, that we've got only a couple of percent of copper and silver. However, the rest these are the wastes and the heaps. And KGHM, International Copper Association, as you can see, they are deposited for something to be used in the future. So we've got already the attempts to do it somehow as the material for the building material, but mainly this is just for the future, which is a very good solution. It's better to wait for and to increase the price for the copper, because we've got 7.5%. So once we've got 10,000, then we try to operate or mine the waste heaps again. And as you can see, this is one of those. You can see it from space. 1,507 million. Then it's the second pond. The first one is recultivated and reclaimed and waiting for the best. And then my ZGH Bolesław, my favorite. Why favorite? This is an example of a very well maintained enterprise. Mr. President Bolesław is the third. So we had the grandparents and grandfather and father. They were all directors there or managers. And he's also in our scientific council. They operate from the very beginning up, from the start to the end. The metalworks, Miasteczko Śląskie and Bolesław. And zinc, which is produced right now, these are the secondary recycled. So what do I take from this part, which is from the primary, from the original? This is on the left side, Gradir, Montenegro, and it belongs to ZGH. But after the enrichment, it's sent to Pomorzany. Then zinc, as it could be recycled with no loss of quality, except for lead. Lead is less expensive. Those materials for zinc, first of all, they are the material for anti-corrosion. If you have Mitsubishi is all their bodies are zinced. I've got 20 years of Mitsubishi and it doesn't corrode. Even if I live in Krakow. So, what does it look like? So we've got the deposit pond operated for flotation. So we have four, as you can see, 4 quarters there. 2 blue ones that are the new operated ones, and then we've got the ones we can see in blue. And we have also then a plant which processes 2 million tons of the waste every year, which is a very good idea. zinc right now is around $4,000 a ton. And I remember that it was, when I studied, it was $70. So please take a look how vast increase of prices. And of course, then they operated the waste again, reoperated, and they are processed right now for quite a limited money, because the waste processing plant cost 40 million zlotys, mainly from the subsidies. So recalculate for the numbers of the metals, processed metal. So this is what it looks like. So this is the Institute of, all the flotation circular machines are being used. Very modern solution, compacted, fully automized. So with just like a dozen or so people as a staff. And today on the upper slide and picture, we can see the material from the deposit pond by the conveyor belt, which goes down from the pond to. So we also have the Bolesław makes very interesting subjects and issues with AGH University, which is the we've got the metal works slabs, and they have quite a lot of content of silver inside. So the idea is, if the muds will be floated, dewatered after dewatering, and with the proper pH, or they will be floated in an acidic surroundings, and then we will add. And due to the also health and safety, which was discussed, which was important, we need to neutralize first, and then could be floated. ZGH operates the existing together with in ZGH Bolesław, there's a huge project of identification of old deposits of the waste in Upper Silesia, mainly in the location we can see here, Piekary, Śląskie and Bytom. There's a huge drillings. Luckily enough, when this project was placed, at 800 meters during the implementation, the price went down to 400 zlotys per meter. So that's why we could twice as much as drillings. So it was tested very thoroughly. And to the materials that we identified, we've got the methodology of enrichment and the processing. So which is it gives us the hope for the recovery and reclamation of the materials stored and deposited in heaps. Then we have the Southern Coal Company, Południowy Koncern Węglowy, Sobieski Janina Brzeszcze mines. So 3 mines, the production, and we can see 2 million tons of the wastes or materials. These are the adjacent materials, anthropogenic materials, or the byproducts, I should say. 2 million a year. What are they? So we can see the minerals and the composition. What can be done with it? Very interesting. We've got quite very interesting initiatives which are financed by the coal company. So we've got the mixed and the beds. How can they be created? Okay. And what do we have? We've got 2 plants for that. in a mine, Sobieski mine, the other one Janina mine. So these are the aggregates of the very good properties, chemical properties from Janina. Then we've got the authorizations, and this is a historical authors of the road around the U-turn around the Chrzanów. So we've got the Jaworzno bypass here, also based by the So these are very spectacular successes, the bypasses, and we've got the anti-flooding embankments in Vistula River, close to Oświęcim. So we had the Janina mine aggregate there. Very good materials that could, if it's not used like that, it could be then had to be the spoil heap, usually senseless. Then we've got the mods, the very small. So we had the waste mod here, coal mods. So it's much easier to use the granular than the shelled or the, because it's then it's easy to burn, and so it burns, ignites easily, and then it's dusted. It's a very interesting initiative that on methane, so the coal, the mine gas, by the Central Mining Institute, but also with the JSW and AGH University. So we've got the Methane Excellence Center, because we've got 1 billion cubic meters of the methane, which is the mining gas from the degasification, and so it's 20 billion of cubic meters of the natural gas, so which is quite a lot. From this 1 billion, only half is captured. 500 million meters is captured and used in the generators. And this is a huge success of JSW, Jastrzębska Spółka Węglowa, which is the Energy Jastrzębie. That was the company, and they have this methane being used, and then it's used for the electricity production. We also have quite a lot of methane captured and recovered from Silesia mine. Also the high methane. So it's not energy, economical and environmental, and the safety operation, of course. Then we had a huge dramatic accident in Pniówek mine a year and a half ago, when we had a dozen or so employees with fatal accidents, and some of the bodies were just found. And of course, then once we capture or vent the methane, it prevents the explosions of methane. Then the next one, urban mining. Everything that we can reclaim from the waste of the town. So we've got the communal waste, 10 million tons a year of a very different morphology. It could be used or reused for different components. And the other thing is also from the buildings as well. Then we've got the byproducts, combustion byproducts. We've got 10 million tons of the bottom ash and the fly ash from the hard coal and lignite, with 100% in 2021 for produce 10 million tons of the fly ash. 1.5 million was exported to Scandinavia for cement factories in Scandinavia. Materials in a Polish Union of Combustion Byproducts, statistics, and then the recycling of the renewables. So it's the PV panels, they are recycled like that from the laboratories. And an important thing, why it's of course profitable, because we have money behind. And the recycling of the propellers of the wind farms, of course I mean the energy production. That's what we avoid, the depositing in this is the Wyoming. They're just covered by sock, but this is an interesting use. So we can have some bridges and elements which are made of the wind farms or the playgrounds for kids. Thank you very much for your attention. Thank you very much, Professor. Questions, please.
Dziękuję. W takim razie płynnie przejdziemy do następnego referatu. Racjonalna gospodarka surowcami mineralnymi w zakładzie górniczym.
Rational processing of the minerals in a coal processing plant in Brzeszcze mine. My name is Arthur Rai. I prepared the rational mineral handling in processing plants. So it was already there mentioned by Professor Barbara Tora, but I would like to supplement it. Here we are. So this Southern Coal Company, Południowy Koncern Węglowy, we've got 3 pillars, Jaworzno, Janina and Brzeszcze. As a matter of fact, it was created in 2005 from Sobieski mine and Janina mine joining. Then it went to Group Tauron, Energy Group, and in 2014 Tauron Mining started. We joined as the last mine, Tauron Wydobycie. In 2015 there's a new Brzeszcze mine in order to adjust our structures to Tauron Mining, Tauron Wydobycie. And right now we're the partner of the Tauron Wydobycie SA. In 2023 as Sobieski, Janina, Brzeszcze mines, we were externalized, spin off in 2024. We had the old name Południowy Koncern Węglowy, which means Southern Coal Company. Then the area of our expertise is from Małopolskie and Silesian voivodeships. Even if we have just 3 mines, we're having around 1/3 of the balance of the deposits in Poland, and the methane 5%. So I would say that our mines, that is Brzeszcze, is the most methane-contained mine in Poland, and of course we use it as a byproduct. Then we've got the mine Brzeszcze in Małopolskie and Śląskie region. So we are in Brzeszcze, Oświęcim and Miedzina. we are to the OUG in Katowice, which is a mining office. And of course also we've got the water authority in Kraków. Then, as the Południowy Koncern, we've got 3 mines, so 3 branches, as I said before. The Brzeszcze mine in 2015, when we joined Tauron, so we've got the production. It was restructured a lot, so it's around 1,500 of employees. The model, we've got 2 walls, 2 long walls in 27 square kilometers actually activities, 5 shafts. 1 is the mining shaft, 2 additional and 2 ventilation shafts. Then 3 of them were moved to the restructuring mine company. So right now our main levels is 640 and 900 meters. These are the levels of production and mining, because these are the deposits of high calorific value coal. They were quite high, from 2 to 4.5 meters. Then we've got the calorific value, it's 28,000 to 29 kilojoules a kilogram, which is quite. Then we are able also to use the product to be sold. 12,000 tons a day. And then the rational handling. So we have the waste, of course, the processing process, and then enrichment. So the coal processing waste. So this is an obligation of the producer to utilize those wastes. We've got two laws in legislation about that, about the waste, and also the excavation. We don't use, and we don't like the word waste. We can say that we as at Brzeszcze, as the first one, we have got the wasteless mine. What does it mean? That would mean that everything which is produced is a product that could be sold on the market. And as the professor said yesterday, and a person from KGHM, apart from coal, which is a commercial, the other minerals are used in the neighborhood, because the cost of transportation are high. After thorough analysis, those materials we started to be used as the product, as the resource and source to build embankments, roads, and the hydrotechnical buildings or structures. And we were approved by the certificate admitting our products of a symbol as the one that could be used for the anti-Atlantic embankments, and D, which is used for roads as the bottom part for the bed. Yesterday, it was last year, as the mine, so we used I would like to say why we should produce the primary minerals if we can use the ones that are already mined out. Let's leave something to the next generation. We don't know what does it look like, but the natural mineral resources, they are not produced every day. So we've got 5 million of tons of coal in different assortments, and we also process 1.7 tons of rock a year. So we produce the waste also. And we've got this is a very interesting thing, that we as Brzeszcze mine, we're such a mine that enriches or process only the higher, the bigger parts, and our slums or our sales are good enough, and we don't need to. We can easily sell it. So the main components of the futile rock, the waste rock, is very good for roads. So we have mainly the main. So then the clays, they are very good for the embankments. So we also produce the coal sills or the muds, and then we would granulate them, and this is kind of a full product used in the energy mixes, or that required by the clients. So these are the examples of how much the byproducts could be used. So here there is also the embankment with the aggregate from Brzeszcze. Then we've got the embankment in Brzeszcze, Vistula River, and we're having on the embankment or at the bank we're having the bicycle route. Then Szanowa Street, the bypass of Kenty, some roads in Brzeszcze as well, for the use of the coast. Some time ago, the mines of concern, we had some problem, a huge problem with the silt, because not everything could be burned immediately. 20% was dedicated for installations, and the remaining part, something has to be done with it. So we used the technologies with Haldex to have the granulate, the grains of the mud, of the coal mud, and its consistence allows us for very good transportation and for the preparation of the energy mixes or blends. So this is what it is. So we don't have too much of the mods, so we help. We process the silt, also the mods, from Janina mine, thanks to which they, in 100% they can have their byproducts as a product, a commercial product. This is the intake, the installation, the plant for processing, and the granulate itself. Summarizing, the directions of the southern concern is striving for the wasteless production. We develop it because it's compatible. When we don't have any waste, we don't have any costs. Environmental nor economical. Then we've got a minimization of cost of the handling of waste handlings, decrease of the environmental fees, additional incomes from the products. When we analyzed it, then right now it's not like that. We are economically positive from the byproducts. We don't subsidize it at all. Then the coal generally is 0.3% of the carbon CO2 in the air. So with a wasteless economy, maybe could be used from the minerals, because the idea is that there's a development, but also we leave something for the future generations to use. As you can see, as the example of the Południowy Koncern Węglowy, Southern Coal Concern, Polish coal mines, by the procedures and monitoring of the technological path, can implement the idea of the wasteless economy. And right now there is more and more of mines try to go the same direction, led by us, to have the production such a way that whatever they produce, which used to be a waste, right now should be the full worth of a product. Thank you. Thank you for an interesting presentation. Questions, please? So we've got you've got your mine in Małopolskie and the mining office, because Woda goes to Kraków, water is authority in Kraków. There's this water structure of the Southern Coal Concern, and this was dominant by the fact that the mining office, Katowice, took over. So we are the hard coal, even if we are in Małopolska, then historically, Brzeszcze for some time, in the 70s and 80s, Brzeszcze was in Silesian, Katowice, so maybe. But I don't know, it was not dramatic, no. So some other mines should take an example. I should go the same way. Then the next article, an representation of the electronic. Thank you very much for the invitation, Mr. Paweł Friebe. So the grinding and milling of, this is the recovery of rare earth metals. That could be used later on for the magnets, neodymic magnets from the shredded and milled rare earths, so for separation, milling, shredding, and so on, grinding. So we had the tests that are very important from different reasons. First of all, if we store or deposit the equipment, then it could be used, it could go to the, it could then transfer to the environment when it's stored, when it's deposited. Then the metals in the electrical equipment appliances, there's a value behind. And let's say this is the hard drive with all the metals behind, and then knowing what's the average components and the value. So in 1 megagram, and it's $10,484. And then we have there's quite a lot of high of risk of the supplies. 9.5 is a high risk, and they are below the 10% of recycling. That would mean that if we found out the replacement is very difficult, so we will have to then for the shredding, or this is a disintegrator used. They used for the shredding with very magnetic parts. So first of all, we designed a special equipment for that, a prototype shredder. So we had the samples of the used electronic appliances. So the research on hard drives, and also the way of shredding of the electrical and electronic appliances with the neodymic magnets. So we can see some elements of the shredder, and then the assumptions, and then we had the design and the engineering for the selection of normalized. Then we've got the calculations behind. In 3, there's the development of a prototype. So maybe can be on. Where you can see those 2 shafts, cutting shafts. But we can see exactly we're going the rotated counter in the counter direction too, and slowly the appliances is shredded. So we've got the shape of the special knife, shredded knife. So here we have a prototype and a product. Then the hard drive was shredded with very strong magnets. We can see here the product. 100% went through the shafts. Nothing was glued to the shaft because we used the materials, the constructions. And the finest is below 35 millimeters. Then manually it was selected, and we've got the parts of the magnets in A, then aluminum, copper, then we've got the printed plates, and then we've got the test for computers, shredding. It was below 40 millimeters each, and also it was separated there. So we've got then the plastic, then the printed circuits, condensers, magnets as well. Then we used the material from the hard drives, manually selected. Then it was demagnetized in the furnace. The muffle furnace above 380 Celsius degrees. Then the magnet loses its properties, So we checked it with a Tesla meter, and this is the below 5 micrometers that will allow us the production of the good product there. And then we've got the vibration mill of 0.8 kilowatt capacity. So we had the tempered steel, hardened steel, cutting or milling basin. So then we had the strainers analysis, and then we had different strainers, 105025. So these are the results of the grinding and milling. So we can see that we've got from 0.35 to, this is 5 seconds, to 0.1 with 115 seconds. We observed an increase of the milling. Then we can see the product of grinding of the finest below 45 micrometers. Also the losses were measured and examined, and they were 1.13% and 0.4 for the sieving or straining. Then we had the other mill, vibration ball mill. Then we also used some different so-called planetary mills and the stream mill. During the PhD thesis, there was a special equipment for the disintegrator, so the grinder, and then it would go to the test for separation. We will have separators electrostatic, magnetic, and optic. The result of milling of the magnets will have to increase the time of milling and grinding. It is necessary also to show the analysis of the of the finest below 5 micrometers, and then the test will be done with the planetary and stream or flux mill. Thank you very much. Thank you for the presentation. Very interesting. The next element. So it's a year and a half for the thesis. So with the test of presentations that will be then presented and published during the next conference. Any other questions? And then the next, this is the risk for the recycling and the elements. Also, Mr. Paweł, on behalf of Rafał Baron, who couldn't join. Why he cannot be with us? All right, he became a father. Thank you very much for the next presentation. Then I'll present the results of the risk of loss of the supplies of the recycling and a way of the replacement of the elements from the small wind farm. Rafał implements the research program of analysis of the carbon print of the neodymium magnets in the circular economy. So it's mainly for the lifetime limitation of the gas turbines. So we've got 14,000 of turbines and 80% of the recyclable. So it's necessary to have the complex recycling. also we have the assessment of the metals generators, also the rare earth metals. So with the lacks of the critical resources and strategic resources and the problems in the chains, mainly the transportation chains, mainly from China, there's a need to develop the recycling materials. The goal of this work should be ensuring the sustainable of supplies of the mainly for the generator of the small wind farms and turbines with NdFeB neodymium magnets. Due to the share of of the critical and strategic elements, we've got the profits economical from the recovery of the valuable elements. So first of all, we had the review of the knowledge, then commercial cooperation and to the generator, methodology of the assembly of the generator, and we defined the parts of the generator. Then the detailed analysis of the chemical compositions of the neodymium magnets, then the risk of the losing of the supplies, and verification of the results and summary of the task. So in 23, the European Commission published the strategic and the critical elements. 24 that are critical and the key for the development of the economy, because there's many projects in everyday life used. Significant part, these are the rare earth elements, 17 elements there. So it doesn't mean that they are very rare earth, but the question is, and the problem is that they are very dispersed all over. So the need and the demand will be much higher than the output. So we had the generator KOMEL. This generator, first of all, has been disassembled. So we wanted to exactly know the main problems. It's the shaft from the generator, then the magnetic force, which is impossible to move the shaft. That's why we use the special equipment for that. Then the laminate grid off. So we had the special equipment for that. Then we've got the disassembly of the magnets with the thermal. So we had a gas burner for that. As a result of this disassembly, we also defined the parts of the generator that the composition will be determined. As a result, we had selection of the materials. So it was split into 10 groups: steel, aluminum, medium magnets, then plastic and composites, paper, and the mix of the very fine materials. So as a result, we had also the mix of the very fine materials, and we'll exactly know what's the composition of this mix. The microscopic technology will be used. So the generator is exposed to the loss of the loss of the supplies because there's the rare earth materials or elements were necessary, and the neodymium magnets, this is iron, neodymium, boron, cobalt, copper, titanium. So that's why we analyzed it thoroughly, and the magnet coming from the generator was crushed in a crusher laboratory and then milled or grinded in a mill, lab mill. So we had a very fine material below 0.2 millimeters per particle. The very fine materials, the result was used by the methodology of the spectrometry and ICP-MS. As the result of the material of generator, so I've got 8 critical and strategic resources here. So it's 9.85%. So we analyzed, the magnet was analyzed in the light of the loss of the supplies and the substitution magnet, substitution factor. So we've got all the elements in RSC for the chemical. So it gives us the assessment. The risk of the is very low to 10, very high risk of the lost or losing of the supplies factor. So they're very high, 9.5. The least risk is for copper, bore, aluminum and titanium. So it's important what the percentage of each element for gallium, praseodymium and neodymium. So very low, is below 10% the way of recycling. For the others, it's above 30%. And then the substitution factor, it's 3 high, that you cannot do it. Then middle one, it is necessary, but it can impact and it's possible with a very low profitability. For the copper, the substitution factor is low. For the others, it's quite small. Aluminium, iron is quite high. For praseodymium, neodymium, dysprosium. They analyzed, so they are very important for the economy, and its lack may impact the functioning of the industrial systems. Basing on the market's prices, we calculated the possible incomes from the recycling. So the value has been done and calculated in one generator, and its value with a recalculation to 1 ton of generators. And we have in dollars so the value for 1 ton of the magnet is $73. For 1 ton, it would be $1,045. Summary. So we had the methodology accepted of the neodymium magnets, elaborated as a PhD thesis. So the parts of the generator have been also assessed, and the generators with the magnets are exposed to the risk of loss of the supplies. So in the composition of the magnet, there are 8 critical elements. 9.84%. From the analysis of the elements in the magnets, there's a huge risk of the losing of the supplies and a very low level of recycling and very low level of the substitution. So we haven't elaborated technology of recycling. We've got the methodology of the disassembly of generator and proving and presenting the economical profits. Thank you for your attention. Will not ask because Rafa will have to answer. Very important part, the risk. Unless you have some questions, maybe we'll try to answer. Nope. And the last one, Mr. Daniel Kowal, of the concept of technology creation of the composites on the impregnated wood waste. Dear Chairman, ladies and gentlemen, I would like to share a couple of thoughts concerning the wood waste and its possibility of its reuse. Here we have the circular economy, but I think that we have it, Professor presented it already precisely. Then, if we are talking about the circular economy, we can say, so H2GEO project, so we use right now the research fund for coal and steel. So we've got the partners, geeks and ITPA, partners from Slovakia and Czech Republic, and its goal is the use of hydrogen. So it's been using their unfortunately, we have also they are the cancerogenic compositions in the they could enter the environment and they can go to atmosphere, which is very dangerous, a hazard for people and for 2021 the European Union limited all the use, and creosote also have been cancelled from the market. So then if we have the lines for utilization, 20 millions of so we've got also the poles with tars, and we have quite a lot of these are the tars all around the electrical poles and masts. it's 770 to millions of numbers, and then Europeans, and then wooden. You can see how huge it is. So the utilization and of the reclamation, from the ecological point of view, the recycling is important, of course. So we've got the cancerogenic substances there. So we also have the loss of the balance of the pole. So what can happen with those elements? We've got the disassembly, the transportation, and then we've got three possibles: recycling, and then burning or depositing. So because it was creosote or tars. So as a matter of fact, we cannot burn it, and then it's depositing, but according to the positions, the electrical poles, mainly, they can only be disposed for after 3 years, up to 3 years. So what could be done? Mechanical scrubbing, then sandblasting, chemical, heat, ozoning, microwaving, enzymatic methods, and biodegradation. We went through the literature. We found also some interesting directions of the recycling of such elements. So the gasification reactors, neutralizations of the hydrocarbons, then biodegradation by the microorganisms. So this is very important, the pH, the humidity, temperature, and also the use of fungi with the citronic acid. They were very positive results in the lab scale. So we proposed a general concept of the technological system, first of all showing what should be done from the very beginning. So first of all, how can we do it and how can we use? First of all, we've got the disassembly, then transportation for sorting. So if we have the poles without any pollution, then the elements, metal elements, will have to be removed. And the most important, the key part, so which is the creosote removal. So we've got distillation by heating in a special ovens. Then with the pyrolysis, high temperature with no air extraction. So with the chemical and then chemical processes. The creosote can be transformed in less toxic. And of course, once the creosote has been removed, then it's cut to the smaller pieces and will be created and transformed. It could be used as the burning fuel or for the composites. The composites that are used very widely. This is what we do. So for preparation of the very small fibers, dried condensationally. So we need to decrease the value of the volume of water content, then the polymer preparation, then the mixing in the proportions, could be dry or wet. Then we add some additions, also antioxidants, improving substances, improving the properties. Then we could use different techniques, injections, and at the end we need to check. We need to have the final processing, so the grinding or something, and then the quality. So such a way, it's got a lot of advantages. Limitation of waste, preservation of the resources, costs, environmental issues. However, it's got some disadvantages. The limitations. So first the chemical standardization of the process and the limitation also as well. Summarizing, the scale is we minimize it, the impact, recycling, these are the key elements for the use, but the deep knowledge, these are the fundamentals of this process. The proposed concept shows us the reuse of this material with no impact. So we had also the systems, and the efficiency will be later on, we hope, will be then approved and confirmed by the lab tests. Thank you very much for the questions, ladies and gentlemen. So I would like to give you information that at 1 there is a lunch, and there's 2 sessions. One starts at So I would like to invite you to the conference. You can see Circular Mind Tech by the Polish Society. We've got the society here. We're very glad to have you here. And the conference will be then in Gdańsk from the 3rd to 6th of June. And it's exactly what we with the session, the circular economy. Primary and the secondary raw materials. Thank you very much. Any other invitations? Thank you very much, and I would like to invite you to lunch. Thanks. So we're having 3 speeches in this time. Mr. Markalita from KOMAG. So for today, we're having different types of equipment. So this is the work that we as KOMAG, but also the industry partner, the Hydromill company. Ladies and gentlemen, in the very first part, I'll try to present the very general goods for the bulk materials. Then I will show you 2 examples of the competence that KOMAG already has. On the other, during the second part, I will show you the hydromill. Mr. Wojciech Bienek will present all the positions, productions, implementations, everything that Hydromill is implementing right now. So, ladies and gentlemen, with the tanks and for the bulk materials, it depends on what kind of type it is of material. We've got to our disposal a couple of technologies, starting from by that steel or it's all up to the so today what we have very close to our investigations, usually they are tanks for the cement or sand or lime, so they could be stationary, permanent on the pedestals or the plinths, and in the nearest future, Wojciech will tell you. So we are going to have a different approach and a different things to be discussed. For the process of engineering, what must be taken into account. So we will have mainly directives, the pressure directive, but also about all everything connected with so for the service and pressurized parts, these are also the requirements for the pressurized tanks, and then quite a lot of standards connected with calculations of those tanks. Then with the pressurized tanks, so we can see those tanks because they're quite tall and slender, I could say. But if you see that, they are quite complicated systems that have a very collaborated and elaborated structure around and inside. These are the systems that could be filled in so they are certain funnels so we've got different types of funnels or the chutes, and this infrastructure is connected with the general access to the tank with the ladders or maybe the safety equipment. Of course, this is all based on some kind of a base which is quite stiff, which will hold the mass and the burden of the material as well to the foundation, let's say, or to the soil level. So we presented a couple of the examples. Unfortunately, generally for the idea, they are very similar to each other. Usually, you know, the ratio between the height and to the diameter is quite high parameter. So we have this about it's based on a certain supporting structure, and I think during the engineering we know so it's connected with the typical with the methodologies of calculations basing on the elements of the definite or finite elements. As a consequence of the designing, at the end of the day, we've got the technical documentation that allows us, the producer, the manufacturer, to start the production with the teams and with a and so on and so on. With regards to the examples of pressurized vessels that were designed or engineered and implemented as well. So the first element of such a tank, this is just a pressurized vessel, very responsible and complex tank. This is 7 cubic meters, 6 cubic meters big, which is filled in and emptied by the pressurized vessel, up to 4 bar for the cement. You can see, when you can see the cross section, there is the infrastructure of all the manholes and all the elements that allow to empty or to so as I said, this is a pressurized vessel. So they should show us what are the, so it's not only the values, but we could propose and design the structure. So to see, you can see everything, how it was combined together, but the structure as well was to show so we'll have 2 tanks to each other, one close to the other. So there was quite a lot of tests concerning with the tests also, and also the pressure transfer up to 4 bars. Of course, it was accepted by the UDT Technical Inspection Office. So the second is also a pressurized part, a little bit different than the previous one. You could see the vertical axis there of for the granulate, even if this is a kind of also this one is supposed to be horizontal. You could see there are some passages, very smooth passages that support the pressurized loads, and they had to be strengthened just to transfer the loads that were supposed to be existing there, as this is also the structure, and for what? This is a bearing capacity structure. So the assumption that we had with our industrial partner, there are 2 systems. So this is just a movable transporter for the cement. So I presented you those 2 tanks that I discussed about. They were installed in a special vehicle, like the pneumatic, and was supposed to provide cement during the ground. And the other one so it is also for cement, a little bit small, with possibilities to how to use it at the rear part of the dozer. So there's quite a lot of the safety possibilities, and then we have the UDT also passed the test of UDT, and the company which is mentioned here could implement it to its close to Krakow. So that would be all from my side for the KOMAG scope. This is what as I said before, this was the approach for the diversification of works, not only for mining institute and mining, but also the industry outside of the mining industry. I would like to give the floor to my colleague from the Hydromel. Ladies and gentlemen, Wojciech Bienek, I'm the representative of Hydromel company from Siemianowice Śląskie. With KOMAG, we've been cooperating for more than a decade. So far, this cooperation was mainly about mining, engineering, designing, and production of the supported roof, mechanized supported roofs. However, with regards to the changes to the market and the diversification of the production, by all those years, we integrated our experience and resources in order to answer the changes needs, market needs. This synergy allows us for implementation of the visions, activization of the team, and expansion to the new areas, demonstrating its abilities of innovation. Finding out and surveying the market, we made a market survey, so we decided to cooperate with KOMAG on production of the tanks. Mainly, the silos. So our company is prepared fully for implementation of such projects. We meet all the standards, quality standards and safety standards as well. We've got the ISO 9001, also 910 certificate of ISO for the welding certificates, and also we also have the weldings for the structures for the railway and structures. So our company is of course prepared for also technologically for production of the tanks. So we're having a very modern park with machines. There's quite a lot of machines, CNCs, that they are very predictable and reliable. The foundation of our company is, of course, the people, qualified engineers, technicians, and welders, grinders as well, locksmiths. As was said, they are the architecture of the precision of each element. We're having quite a lot of experience. Basing on the engineering documentation, we implemented more than 10 or dozens of the silos in projects. So we transferred them in a functional construction structures. We can manufacture the tanks, silos, some from 30 to 100 tons. Also, it's each 10 tons bigger, and also 100 tons, 150 tons, 200 tons. And we've got usually the 2 meters, from 2 meters to 3.5 meters as the diameter of the silo. And those silos also they have filters, they are equipped with filters, also the supporting structures and ladders, barriers, fences, and quite a lot of different elements for on site. That's an example of the implementation. This is a sand silo of 30 tons. It's being produced this year, and it was for the tram company in Warsaw. So it was documentation from engineering documentation was from the employer. We can see only just the shell. We also had the additional equipment, so the barriers and the fences, ladders, external ladders, also the platforms, the chutes and the loading pipelines, also for stubs and nozzles for safety valves and existing remaining equipment. Of course, it's protected for anti-corrosion. So it's the SA.5 and also by the epoxy. The color is selected. So it was not a typical. This silo was 80 tons. As we can see here, it's got additional supporting structure, which is made out of special profiles and pipelines and pipes. So it's a shell of the diameter of 3 meters. There's additional manhole, also with the fences and structures. So it was prepared and painted in white. Last year we prepared the whole full set of the. So it was 90 cubic meters of the diameter of 3.2. Those two we had with the double funnel, double chutes, and double supporting structures. Some other implementations and applications. We also built some other structures, steel structures like platforms, fences, barriers. So we've got So we also have the mixers, transporters, also the conveyor belts and conveyors. Our competence and infrastructure, it's not only the silos. We can also build the special pressurized vessels and tanks. We also have the UDT certification for production of the pressurized tanks for chemicals, also the harmful materials, and so on and so on. For the future, we're thinking about this mobile silos. This is just a picture. We haven't produced such a silo, mobile silo, but I do think that with cooperation with KOMAG, we will get there as well. We'll then produce it. They've got a special advantage that it's possible to move them quickly in a different location, and no need to build foundation for kind of silo. And they are perfect for the use in the locations with a limited outer space. So I think that the cooperation with KOMAG will be fruitful and will manufacture this type of the mobile silos. Thank you very much for your attention.
Dziękuję bardzo. Rzeczywiście bardzo ciekawa prezentacja. Nie wyobrażałam sobie, że aż taka różnorodność może być wśród kierunków. Ten silos drzewały najlepszy na końcu. Proszę Państwa, czy jakieś pytania? Jeżeli nie ma, to bardzo proszę o przedstawienie następnej prezentacji maszyny i urządzenia przeróbcze w konstrukcji Instytutu Magazynowania Energii. Oferta dla przemysłu.
So this is an offer for the mining industry. So we'll have KOMEKO, environmental friendly industry. Good morning. Good afternoon is actually right now. Thank you very much for having me here. It's very short on the machines and the processing plants of the Institute of Non-Ferritic Metals, and I wanted to say just that Mr. Adam, Krzysztof, Szczepak and Tomasz, and also for the support and the participation in this conference with our and Mr. Rafał Walczak, who is with us at the same plant. With regards to the center of the mineral materials processing, we deal with everything actually, which is connected with the processing of the primary materials, also the secondary waste that could be they are the kind of byproducts from the secondary materials, as we can say it from the raw materials. They are the non-ferritic metals, but also coals, carbons, and also the aggregates, minerals for processing. The same for the wastes, So we've got the byproduct as well, also the metalworks wastes and the ones from the metallurgy industry. For the scale, so this is just from the lab until the pilot plants. So as a matter of fact, we're having with a group of we can have using the 1 cubic meters for, we can go to the processing plant or we can have the test, mainly the test for aeration with 6 meters. This is the PCBs, batteries, of course the PV panels, but also the byproducts, waste on the civil works. We've got quite a very wide scope of the mineral byproducts from the scallop and lab scale, and our precious pearl is the flotation. So our equipment that we use all the time, the first one is hydrocyclone, which is the EML, in cooperation with ZAM. So the new structures and new technologies for enrichment and we started the works on the new hydrocyclones, and then in 2012 we got the hydrocyclones for the industrial tests in KGHM, and then in 2015 we also checked our hydrocyclones in Kawukach, Szczygłowice, and we started the implementation of the investment in KGHM. So we're during the implementation, as we can say, there's quite a lot of hydrocyclones to be used for its efficiencies from pressure, and then also what we have the hydrocyclones, what are they? So first of all, this is HE500 with regards to the solutions and outside abroad foreign solutions, the decrease of the costs, longer lifetime and the reliable operation, then efficiency, then much better the efficiency of hydrocyclones. So as what said, this is HE1500 per 12. So it's a decrease of, so this is also the delivering, the lowering of the costs and the wear parts and spare parts. So for the nozzles, lifetime in our hydrocyclones, it's 8,800 to 26,000 hours of operation, including the outer nozzle. This would be 3,500, in hour is up to 9,000. Or implemented tasks, as we said in KGHM, there's more than 360. We've got 363 hydrocyclones and many batteries. So we have the photographs from Pniówek here, coal mine. So it was the idea that they could be used, and we would like to discuss about the potential next possibilities of cooperation. And then our next product, these are the flotation equipment. So when we had Mr. Ślusarek as the manager, so we started from the Ether. So we've got the IZ, and then we can also have the aeration, and also we can check them to the float.
Centrum badawczym, które ma instalację pilotową do wykonywania takich testów. Posiadamy aeratory maszyn
So we've got the aerators for flotation of different type.
który uzyskał dokumenty patentowe i zastrzeżenia. Posiadamy typ szereg maszyn typu IF.
So we've got the IF,
Szereg od IF 20 do
from IF to IF 100.
Posiadamy maszynę 160-metrową i jesteśmy otwarci
And we are open for any other solutions. Of course, the flotation machines that will meet your requirements.
Oprócz tego możemy
Apart from that, we could also suggest an INC and the control of the flotation, then the system of automatic regulation of technological air to for flotation. We can have also the flow meter, automatic dosing of the samples, and also system of the regulation for the flotation of coal. Yes, they have been already yes, but only outside of Poland. Why? Because for Jasmus, it's being decommissioned. We had the IF 330 and IF 100, the same for Dutow and Anna. We had the IF 45, and we have also mainly the Jasmus in China. So they are 5 processing plants, coal processing plants. So I've got that's our small success there in those plants. That's IF45W in Shanxi Bailong. Then we've got the flotation also for ZGH Bolesław, for Olkusz Pomorzane, for the primary raw material or the resource. We had our equipment there and the flotation and a major blend at gallons. The same with our flotation means the flotation of the flotation wastes and byproducts, also the silts with silver silts. Also in KGHM Zedwar-Rudna, all the equipment without IMN. So we had IF57R. Thank you. We're happy to talk to you. There's 3 of us, and we'll be glad to discuss with you. Any other questions? If not, I would like to have that I'm here with Mike. We have a very spectacular case of cooperation of the non-ferritic with COMEX and AGH University within the frame financed in CBWR. So we built together the hydrocyclones that we discussed about, and also the grains of the materials measurements at the grain level measured in 3 products: the feed, the product, and the product. So it was a very interesting solution, and it was functioning for some time in Polkowice. So first of all, this was the hydrocycle manufacturer in KGHM, the Institute of Non-Ferrous Metals. There is 400 of them, and then very innovative solutions with a continuous measurement of the grain, of the finest of the the finest of the systems and particles. So it's a very interesting solution. But also, the new thing came for the flotation equipment. Then the Institute of Non-Ferrous Metals. It's the better use of the space. So also have the coal processing plant after the enrichment of the processing of the coal in Czech Republic. It was a very modern plant dedicated especially for the heap, for the coal heap processing, because it was burning all the time. The small heap was burning and is burning all the time. So it's 100 years old and we cannot put it out because, as you can see, it's very, well, it's a little bit of coal and also more than 8.5 gigajoule. This was impossible, so that's why we've got the Polish equipment and the plant there. Very interesting. AGH University, we made the testing of the samples of coal on the coal heap. So this, of course, not only us, but with the Bańska Szkoła. So Polish, this is a Polish equipment, the flotation equipment of the Institute for Non-Ferrous Metals. So we've got the reports. How many strainers we had in Hermanice? 13. 13 strainers. So I think it was built by Polish equipment. Very modern. Unfortunately, it requires some reconstruction, but it is supposed to start this year. So probably it will start its operation soon. The goal was the coal recovery, but mainly the aggregate and selling it as a product as well. Very interesting cooperation of different companies. Any other questions? If not, then thank you very much. The next COMEX, Dr. Jacek Kołacz, coal processing with the use of the Röntgen optical CXR from the COMEX. Thank you very much. So I'm really glad to be here and to present our innovative methods of sorting or enrichment of coal, but not only, by our sorters, Röntgen sorters. The co-authors, Jacek Kołacz, Borgowicz, Walter Premio, Hart. Where are we? So we've got two. You can't see it, but our company was created in 2003 in Norway, and the daughter company 2007 in Poland, Kraków, COMEX Polska, and it's been functioning all the time until today. So what we deal with mainly the milling systems of the fine particles. In the last 10 years, we developed also the separation methodologies with the sorting equipment. The enrichment of coal, usually it's the, so usually there is just the grainage. We also had the baths for the silts and the muds, then the flotation, of course. This is with water. We also have the possibilities to have the enrichment by selective crushing, what I would like to show you by the sorting X-ray or optical systems, which is an X-ray, as a competition to the vibration tables and or the we could have a much more interesting solutions. We'll see this operating principle film. So I've got a vibration conveyor that spreads the material as the singular layer of the materials, then it goes through the X-ray. Then we have additional computers and so on. Mainly it's used the Röntgen X-ray sensor. So the material is the singular layer, and at the end we've got the nozzles. Might be a product, might be a byproduct or a waste. So this is how it goes. The feed. It's 3 meters per second in singular layer. Then it goes to the X-ray gate, and we've got the nozzles that this. So we can see this is easily to present how it works. This is very. It's 4 microseconds. So it's below 1 second because it's required for the shooting of the particles. We do not need. So we've got the lab sorters and scanners. We've got 2 sorters, 2 types. We can have quite a lot of works, R&D works, and also the industrial sorter, which is 1 meter, 1 meter, meter and a half, 2 meters, and the new ones, 3,000 centimeters, 3 meters, the very wide industrial sorter. Right now we are using the parallel solutions. This is quite a big installation here in China. When we put 3 2-meter sorters installed in parallel with a lot of feed, this would be 800 tons an hour, so it's quite a lot. Technology X-ray. So this is a case of it could be a couple of thousands an hour. So we've got a coal here in green. We're having coal here on the right side. This is the usage for the ore enrichment of metal. This is a zinc and lead. So we can see the density of the materials, and we'll come back to it. So what is a detection? Detection is in the horizontal way. We've got all the photons, and the verticals, the signal that we get from the detectors. Everything so that each material's got its different characteristics. For the Röntgen, for the X-ray. So we are easy. It's easy to distinguish. It's quite a complicated analysis, but today it's very accurate. It's been used for the systems, but also in medicine. So we can see coal here. We know that it is black, so you can see the differences. However, if it's selected it's all got the same materials, but here we can see much more. In blue, then we've got stone, and in the middle we've got the layers, and then the difference between one and the other one, we're able to know what's the density, when they can be used for the pre-concentration, the existing technological system, and also we can have combined it with the existing system of enrichment or processing, also for the final products to be enriched. What are the benefits? Most of all, the lower costs. So it's a reduction of cost of operation. It's from 10 to 12, 20 times lower cost of operation. So this is the cost of components and energy, and so on and so on. Then increase of the quality of the product, so we've got additional separation of sulfur. The reduction of the carrier or elimination of the heavy fluids or liquids. And there's no water or the decrease of water level for the processing. I think the most important thing is that we are able to adjust it to the needs, exactly to the needs of the processing, that means enrichment, for the capacity. So if we need to, it's very easy to increase the capacity by additional one more sorter or the sorter units, or you can combine them. We can have, for example, in the beginning, then the cleaning or fine cleaning for the product, for the byproduct and the product. So these are we will have feed, calorific value, 22.72, then 21% was ash, and then we put a product on the right side when we have the calorific value to 27 megajoules, and it's ash 9.2 with 80% of yield for the calorific. And then we also have very similar result, 21.3 for coal with 6.4. By the cost of the yield, it is 67.5. It's possible to have quite similar. And then the other example we can have here, this is then the processing is 33.7. Then we increase it to 23.3, reduction of ash to 23. However, yield is 27, so the product yield is much higher. And then from the 22.7 of ash, we can have 16.3 more, but by the decrease of the yield. So this is just a fine-tuning of the sorting system. And one more system from the coal in the energy sector, quite a good quality, 24.3, 14% of ash. By just the fraction of stone removal, it was 81 and 6% of the yield. Right now, we can increase to 25.6. So this is, as a matter of fact, just before the combustion, the burning. It was for coal, but I would like to show and present you also some different examples with different cases of processing. For the critical elements, we can see the materials that were presented. It's a couple of percent only, maybe a percent only in a very rich ores. So the concentration might enrich and improve the process. So this is what we could do via the analysis. It's not only to calculate the materials in yellow and blue of a higher density materials, but also where we have the parts. By the AI models, we are ready and able to assess if the material has got something interesting, something that we're looking for, like let's say the ore of gold is dispersed and then not necessarily it's not visible by the green or yellow, but the location and the dispersion is very important for the character. So it's an X-ray with some other AI material, let's say for the RGB and cameras, or the infrared, especially the hyperspectral, gives us a lot of possibilities. This was just an example, but frankly speaking, we could use the X-ray here, what I said, and it gives us the possibility to find out the materials. However, what is important is the connection with some other detectors, some other sensors, let's say also HS camera, and it's visible to show us, to present much more than just the visual. We could also have the X-ray, collimated X-ray, and HSI, and then we're ready and we're able to say a lot about the material, if it's the proper one, or we can qualify it in a different way. So right now we've got, this is just a scanning, a very small, but we're ready to identify the compositions of the materials. So for sure, we build the sorting materials and equipment. It is enough to qualify that this material is answering the fraction of the waste or the product. Then the implementation center, we always start from the tests in our lab in Oświęcim with all the possible detectors and sensors. We're ready to find out what technology is used, could be used to identify the material. Then we've got tests, we optimize physical fractions on a small scale and a pilot scale. So we're able to, because this is a closed loop, we're able to simulate the production of higher scale, sometimes 150 or 100 tons an hour, because the same material comes and returns to the sorting. So we're able to have the combination of sensors and feeds are enough for the separation. Of course, we can build the container also, implement application in a very nice conditions. We can move it to any place for any process actually, and then we can say if it gives us the proper or expected results. We also have a tent application or an open. This is a application in Brazil in tropical conditions, high temperature and high humidity. It can operate also. Summary: the new technology with some other detectors and sensors, and visible light, also the infrared, gives us a very competitive possibility for comparison with the traditional processing methodologies. For separation of the hard coal, it is possible to lower the cost, eliminate water. Also, separation of some other elements that are not needed in the sample. We could use separation of the small and big processing plants. So it's up to the capacity, and metallic ores, it's possible to have very efficient pre-concentration ores with a very small contents, like the material, mainly for copper, coal, gold, and some rare earth materials or elements. Of course, then we've got the power consumption is much lower, it's lowered. We reduce water use, and we also decrease the number of the dust, and we can have very low costs for this process, between 1/10 or €2 per ton. So the operational costs are really low. It's mainly, we've got the applications in all over the world. We're not present in Antarctica. 70 installations, mainly for coal. Also the metallic ores, zinc, lead, gold, copper. Also the rare earth elements, separation of the recycling of metals, and some research institutes and universities when they were used for. Thank you very much.
Dziękuję bardzo za rewelacyjną
Thank you very much for the
prezentację. Czy jakieś pytania?
excellent presentation. Any questions? So I was at this existing station Bitom, and it makes a huge impression. But the question is, we've got a segregation by the air, compressed air. Don't we have there especially a lot of dust and atmospheric? Then do you take into account, the explosive atmosphere with air and of course, if coal is completely cold, then we've got there's quite an explosive atmosphere. It's the level of the dust very close to the concentration of the explosive, so we've got quite a lot independent dust removal, the drain, which is the ventilation, but it's not always there because very often the coal is wet because it comes from the previous process, because we cannot separate the coal from the zero fraction, from the very small. 10 millimeters must go through the strainers. Very often it's go in the water. This is a dry process, but with a spray. So we've got quite a limited dust there, the coal dust. It's taken into account, and independently it is assessed by the specialist company. It's adjusted to the system, to this client.
Państwa, czy jeszcze jakieś pytania?
Any other questions?
Ja sobie pozwolę też, bo miałam przyjemność
I had a chance to have a look at
jeszcze w starej lokalizacji.
the old location,
Tam Państwo separowali ziemniaki.
and you separated
Komentarza na temat
potatoes.
koniecznie ziemniaków, ale
Can you comment what other materials could be used, not a mineral, but mainly the communal? Yes, this is right. The separation of the vegetables, we supplied it as a pilot plant, but it was not Röntgen, but optical. We wanted to find out the condition of the quality of the skin or the peel of the potatoes, in order to avoid the rotting processes. And if we gather the vegetables. It was a very specialistic use, but allowed us the opening of a different line of separation. It was in a one line of veggies, and it was analyzed very thoroughly from all over the price. So we take into account for the waste, for the more or less the building or construction. So probably yes. And the last chance for the questions. If not, thank you very much.
Proszę Państwa, teraz będziemy mieli festiwal ZG Sobieski i ZG Janina. Dwa kolejne artykuły.
We've got two,
Przez Pana,
Mr. Łukasz Rzeźniczek.
przepraszam, zakończyłam nazwisko. Bardzo przepraszam. Optymalizacja produkcji.
Optimization of production of assortments in a southern coal concern in adjustment to the Sobieski. So this is a Sobieski mine. There is a... Good afternoon. My name is Łukasz Rzeźniczek. I'm representative of the Sobieski mine. And it's optimization of the assortments in our mine. What is very similar to our colleagues from Sobieski and so on. It was presented in the morning. From the information from yesterday, from the activity, it is Sobieski has concession, a license for until 2023, and the resources is 350 million tons. The area, two voivodeships, Silesian and Małopolskie. So we have 2,500 people for employees, two long walls, 14 kilometers, square kilometers. The system is two ways, one for the skip, the other one we've got a 2,000 where the structures goes the coal processing plant, and we've got the data there on the capacity and the possibilities. Our mechanical processing plant has got two separate departments, two separate buildings. The first one, the older one, we've got the kiddies processing enrichment from the 200 to 400. So, and allows to have two products or three products. It's up to the parameters of coal or the feed that we're having. We've got assortments, which is the cube 2, nuts, and P. The other one we've got Cieszę, then we've got the muds and the sludges. It's 40 millimeters to 0. So we've got two deposits here, OM15L, OM15P, then we've got the hydrocyclones, HS500 and HSC350. We've got the spiral enrichment, and then this is three products there. We had the modernization in 2019, 2018. So mainly this is just the piece 2, and the mud 1 and mud 2, or the slit 1, slit 2. Due to our observation of the markets and the forecasts, as all of us, as every factory or company, we have to go further and further and adjust its production to what's necessary and needed on the market. So we've got the decrease of the need for the bigger lumps. However, we've got more and more needs for the finer blends, which is for the qualified fuel, for the so-called eco-coal. So the decrease, you don't know that over the last years and also all the time this is implemented, the individual households, they replace their or exchange their central heating boilers. We've got the different technologies. So that's why our plant made the actions for possibilities of the high assortments once we don't have those wider assortments or bigger parts. Right now we are implementing the investments. This investment has got some stages. For the implementation, we had a functional program first that gave us this possibility. So the main elements, we've got the pre-selection, and then also the execution to all the crushing and classification of assortments is then directly at the processing plant. Location, as you can see, but we are now after some works to be done. I will show you also the new plans. What does it look like today? So first of all, this is just a classification. We've got the replacement of the old crusher. That would mean that usually we've got 300 millimeters. Right now we changed it for 200 millimeters. Then it goes to the crusher, and this is the first stage. This is first of all so this is a change for the strainers and additional place for, and we've got the exchange of the crusher itself. As we're here, with the crusher and so on, we've got the special 306. So I think that we are here just before entering. The second point for the feed, these are the reconstruction of the so I've got two strainers or two sieves. The old tank, it was not allowed to have it, so we've got a different once we wanted to increase it, it was done last year, this part. So with the exchange of the chute, for having this feed better dispersed for the classification methodologies. We can see that it's much better than used to be before. Right now we are our main goal in this stage, there is the crushing of the assortments, the so-called big assortments. Right now we are here to find out how it should be installed. We need to take into account the fact that it's all presented in existing, and it all has to be somewhere presented. So that's why we have everything there, additional conveyor belts. So it's what we have. For this installation, we've got the Obrimeldi. So we had this presentation, and we had a look, and we do think that it will be good for us as well. However, we did not have such things before. So this is something which is good for us as well. It's a separate element. So how can we summarize it? First of all, that we try to adjust exactly to the needs of the market, and we're trying to change our technological paths. It's mainly up to 300 pages, so this task will allow us, to control the assortments and the sizes up to the needs, and it does not close also the possibility of production for the assortments later on if needed. The system is designed in such a way that we should have the possibility to crush the assortments, but also to have the production if needed. Thank you very much for the attention. Thanks a lot. Do you have any questions? Then there's one detail I wanted to point out at the crusher. Don't you think there will be a lot of very small fines, grains? So we were there to work. I think that it should be, we shouldn't have too many so-called subgrains.
Jeżeli nie ma pytań, to poproszę kolejną prezentację. Teraz będzie z zakładu górniczego Janina. Jeżeli dobrze mam zapisane, pan Krzysztof Grzyba. Kontynuacja działań modernizacyjnych
So with the modernization on in Janina, Southern Coal Concern.
Halo, przepraszam za głos. Dzień dobry, witam Państwa serdecznie. Nazywam się Krzysztof Grzyba.
Krzysztof Grzyba. I would like to represent the coal mine Janina.
Przedstawię Państwu kontynuację działań
So there's a continuation of the modernization in Janina.
Janinie, jak trzeci, to już było przedstawiane w Brzeszczy.
It was presented in Brzeszcze. Sobieski was presented as well. So right now, time for Janina mine, the third mine. This is the oldest, yes, as far as I know, this is the oldest mine. So we're having a very short historical. I will show it as well, a couple of words from the very beginning. In 24, Janina was there. Then the structure of Tauron again, then we left group of Tauron, and then 24. So we had two, and the license is valid until 21 tons. So as it said before, two. So the most important information, it was just above 2,000 zlotys, so 81 square kilometers, five shafts, got a very good coal, and also got the sloped way, and we have the deepest, which is 820 meters. As we can see, it's from 20,006 to 28 kilojoules per kilogram. That I would like to introduce the modernization and refurbishments, what I said before. It was already discussed during the last by Mr. Jachimczyk, who couldn't be with us today. I wanted to, and let's, so the main goal for Janina is the 4.0. So these are the changes actually, innovations, so it's more automatic and much better. So with the modernizations, and the goal is a very important subject. Monitoring of production and the real time. So this is what we have in 2023. You can see right now the additional. So for sure we have quite a lot of important. The fraction is better washed from 2 meters to 0, and for sure it's improved the grain selection. We don't have the very small grains on the machine, which is much better for our production. So I've got a permanent magnet, 100, 122. Frankly speaking, this is something which just before all the ferromagnetic magnets are caught and selected. All metallic or ferrous materials are being removed. We've got two separators, and of course they're also quite, but we need to take care also of the coal. This is what we have right now, the magnetic separator, which allowed us to eliminate all the ferromagnetic pollutions and or strange objects. Then we've got the two strainers and two systems from 0 to. Then we have, most probably you can see the sieves and strainers here. You can see the strainers PWE2444 from September 2023. Here we've got a very similar sieve to the other technological line. 2 months later. Then our next was a modernization and refurbishment of the sieve for the strainer for the rock. It's 2.25 for 25 to 200. It's only one strainer for two. We've got here a replacement of additional strainers, TWE. So these are for the dewatering of the product. It's much better. And we've got a more commercial coal production. As you know, 4 points, lube points. So for sure, it's got a longer time of operation, the lifetime of operation. Frankly speaking, we have the stuff free, with service free for the lubrication for lube, because we just checked if the grease should be also there, and this is all just to have it empty for all the bearings. So it's a very good idea, and it's much better for our plant. Here we've got the implemented in 2024 2 valve pipes with vibrators. So the centrifuges exchange, so it's much better quality for the sludges, and we've got the lower humidity and a higher calorific value, a better heat rate. And then we have also the continuation 24-26. This would be the production of the mix and blends by the granular. So we can see here, we've got the installations right now. If we have a car, a truck, this is the end of our installations. So we could have we can have exactly what you can see in red. These are the things that will be engineered and executed, and they will have addition directly to the chutes, and we'll have to the wire, cameras, everything will be economical and autonomous. For sure, it will make it much easier for the energy mixes. For modernization in 2.0, we will have also the spirals to be exchanged. We will exchange or replace our centrifuges. So we'll have the new EDB centrifuges. For sure, the replacement of Centrifuges, of course, will give us more reliable and faster application. We need to build a new infrastructure, some buildings, civil works, installations, also the conveyors. It's not only the conveyors, but also all the adjustment or balance of the plant. Here we have the centrifuges, EBW from the United States, as far as I know. Most probably they are in a harbor and port. So what else can be said? Modernization of the technological line of processing of 200 to 0. So we'll have less water content, smaller water content, which is very difficult for now. Better calorific value, sulfur, and something we find for. Summarizing and wrapping up, in 2023-24, the modernization Janina in Południowy Koncerholm made better production, less failure frequency of the equipment and failure rate, higher efficiency with the parameters that are most important, and optimization of costs. The modernization of the implement allows us to meet the requirements. Thank you very much. Thanks a lot. Thank you. Any questions? If not, I will ask you. Salt. So I've got additional spraying on the fresh water, so that's why we've got additional sprays, thanks to which we've got much better, and we'll limit the acceptable values. I'm asking because it was a project there to have the evaporator or this desalination, yes. Time will tell. Thanks a lot, thank you. Of course, greetings to Mr. Jachimczyk, because most probably he's there watching you. And the last presentation, two presentations by two Marcins. If the work could be more node. This is your package. All right, here you go. Good afternoon. Thank you very much for the invitation. Very nice invitation. Nord Actuators and Drives. The engineers of sales, Marcin Habał, Marcin Piotrowski. And of course, we know exactly that work in a coal processing plant. It's really a very nice, this is a pleasure, but it could be even more pleasure. So that's why we've got the noise. We would like to concentrate on noise. I was learning about noise, so I will tell you. Let's think, what is it, a noise? Noise is the sound that we do not like. Yesterday it was quite loud, but it was a noise. A noise is the sound or sounds that are not wanted in the place, so we need to fight. So what are we talking about? So it's acoustic pressure and the point, and usually it's in decibels. Why? Because they are completely different. There's quite a lot of discrepancies, like 100 millions of microscales. It's much better to say it's 140 decibels. If it's quiet somewhere, I would say the level level of 40 decibels. The admissible level inside, this is 85 decibels during the 8 hours. Then we don't have any failure to our or fracture to our ears. Then what's the level of the sounds we can hear? Normal person we can see 20 hertz to 20 kilohertz. Above we've got ultrasounds, infrasounds. Of course, some of the animals they can hear, we cannot. A very important information is when we have the tires, now the noise of the tires is given. Please, but if we can hear the level of the equipment is different, then the level of the acoustic pressure must change 3 decibels. So if someone says that it's 70 decibels, not 71, we will not hear it. We will not hear a difference. Let's look at the practice application. So I was asked once to see the NOR drives. We've got a mine when we had two drives, one 50 gigawatts, the other 30 kilowatts. If you can hear, it's just a ventilator, just a fan. You can't hear any noise from the gear. But it's all about noise. We can hear the noise of the stones, then you can hear only the noise of the fan. You cannot hear the gearbox. And then there's another company in Novosola, in our factory. Most probably you saw the motors assembly. There's the noise from the motor, but you cannot have anything from the gearbox. Then we'll have the noise of the ventilator or the fan, cooling fan. 4. So each drive is started and heard and tested, thanks to which we're sure that all is fine, and the persons, the assemblers, can find out what are the differences. So we're basing on the measurements. So this is a catalog of the motors when we have all the motors inside. You can see also the acoustic pressure and what is the difference between the acoustic power and acoustic pressure. So if we measure the noise, there is usually 1 meter, a microphone is from the equipment, and we measure the acoustic pressure. But then let's see, it could be a ball, for example, and then we can be at the building. If we can have a ball from 85 decibels and we go outside, then the surface of the air grows with relation to the surface of this ball or a saw. If it's from the building, then the surface of the building, we don't have an increase. We measure acoustic pressure, and additional is the power of the acoustic, which thinks about the source, the relation source. We can have a map of the noise hazards where we have the capacity, the power, and it's manually calculated. And the data could be found in our catalogs with the values of our. I think the motors are done, but of course the gearbox is not quite. It's completely silent. There's a lot of things happening. You can have a look inside to the motor reductor. What we can see there, a very good idea was to organize a reductor in such a way that the cone should not be the first one, because of the so we can have it's much higher and the lower, so it gives us additional advantage. When I saw one thing in the very beginning, at the end we'll have a competition, and the answer is not, but you will have during our discussions, and it's an award also. I never said that because it's going to be very difficult. We've got good competitors here. The fact that we've got the cone wheels below means that they are lubed all the time, even if we have any leakage, are safer there. It seems to be very small. How about the big ones? Is it the very same construction? It's very similar, mainly the casings, which gives us the repetitions, because all the casings are monoblocks, so one part, and that means that all the parts and all the gearboxes are very repetitive, very similar, also with the noise. And we have the information that if somebody invests in such a drive of node, they can hear a difference. So that's why there's a presentation. One more thing is worth mentioning, because the noise from it's just a cooperation of the wheels and the gears. The gears, they are grinded in class 6 or 7. Fourth class these are the measurement instruments. If we have the 6 and 7, they do not wear out. From the very beginning to they have the same readiness to operate. Why? The question was, when do we need to exchange the oil? After 4 years or 20,000 hours of operation. So we do not. Of course, if there's a synthetic oil, of course, yes. Thanks to that, the accuracy of execution and the quality of everything, they go through the very rigorous testing. But it's not only, so the question, where to go for vacation? Well, thinking about vacation, I'm going to Balkans, and I wanted to go to the Borów pit mine. It's not coal actually, but North Macedonia. I would like to have a look, the work, the operation, and the belts of 6 kilometers. For sure you know that our small drives, motor reductors, but here we have like 3 times 400 kV and power belt speed length. So we've got shrink discs here 4 meters per hour and the length 5 kilometers. So this is the 11, it's not the biggest, it's not the largest, but time's up, so let's go on. What's new in Nord? Most probably you saw our plant in Nowa Sól. Today it's 400 people operational. It's 1,000, but with the parts, the shrinks and so on, and shafts, 100,000 a week. Then we've got also in Gliwice, we have the electrical motors factory, very close to the western Poland. Right now it's being developed. It's brand new because we started in 2018, but we can see that it was last year. Then the next slide. And one can say that this is the last that I found. But right now, this factory is already finished and developed and quite big. Right now, this is 2,000 motors a day. And the plans are for 5,000 motors a day. In Zakrzów, this is the customer service, but also so for the customer service there. But one of the goals was to give you some knowledge about with the Nord Academy, with the trainings for everybody and finishing, servicing and operation of post-selling. The trainings, of course, could be done also on site, at your site. But we're prepared to do it in a very good and wide scope. And the quiz is, but who's going to be the winner? If you know, please raise your hand and then I'll ask if you have the right answer. Doesn't have a monoblock. Yes, very good. They're all monoblocks. Congratulations. And thank you very much. Do you have any questions? I'm really interested in the fact so the noise 1 meter measurements, 1 meter from the equipment, but in which direction it goes? Because this noise is different with the ventilator, outlet from the side. Is it the maximum or the average? So you measure around and the maximum amount is given. And any other questions? Thank you very much. Thank you. Thank you very much to both Marcins. Thank you, all of you. 10 minutes of the break. So we'll start 5 to 5. Thank you very much.
elektrownia miała kamerę termowizyjną, to był luksus. I nie mieliśmy dronu. Później ze Stasiem właśnie żeśmy drona wymyślili.
Proszę pana,
To
mogę
z
sobie wziąć
wysokich budynków.
nakrętkę? No to zbieram.
Nie jest
Leżała
A
tu,
to już nie wolno zbierać.
ale ja jestem przeciwko niewolności. Mam taką koleżankę. Mam taką koleżankę z
Polski
pracy, że mi
KOMEKO tam jest.
która mi każe
Czyli
zbierać.
pan jest pierwszy na naszej sesji.
Tak.
No, czyli ta jedna brakująca, co?
No właśnie,
Nie mieliśmy.
to jest ta brakująca.
Korski na polecie 24.
I spróbowałem zobaczyć z kamery termowizyjnej, jak to wygląda z komina elektrowni. No i potem z kilku punktów robiliśmy, nie będę tego pokazywał teraz, no ale dostaliśmy na kongresie, pierwszym kongresie inżynierii środowiska ze Stasiem Kwaśniewskim nagrodę.
Cudnie, no. Fajnie, to jest takie budujące.
5 lat gasiłem tą elektrownię.
No, ale ona się
Przez
paliła.
pierwszy
Ale ona
rok
się paliła 20 albo więcej. A się od zawsze paliła.
ona się paliła udokumentowane 62 rok.
No, czyli 40
Cały czas
parę.
sypali. Cały czas sypali. A teraz mój pryncypał
tej sesji jest 5 referatów, wydaje się mocno ciekawych i zróżnicowanych, dotykających różnych obszarów i zarówno będą to środowisko odpadów górniczych, będą to informacje dotyczące węgla kamiennego, cyklu i również pierwszym prelegentem jest pan dr Jacek Kolski z Instytutu KOMAG, który przedstawi referat o wpływu warunkowania i ograniczenia metod zdalnego monitoringu składowisk odpadów górniczych. Zapraszam.
Dzień dobry Państwu. Powiem w ten sposób. Strony systemy zdalnego monitorowania są obecne w naszym życiu bardzo. Za 5 miało się zacząć. 16:50 zgodnie z planem. 16:50, panie profesorze, no ale trudno. Ale to może ja będę mówił, dobrze? Jak już zacząłem. Natomiast warto się zastanowić.
So it's good to think about the possibilities of use of the technologies of the remote monitoring. I will not tell you about drones today, of the use of the methodologies of, there's quite a lot of them.
Będę mówił o tym, co o możliwości, czy bardziej ograniczeniach właśnie uwarunkowania, przede wszystkim w zastosowaniu zdalnego monitoringu do kontroli składowisk odpadów pogórniczych z kopalń węgla kamiennego. Natomiast wspomnę też
So let me also say that, about the heaps, coal heaps, because right now we still have
proszę Państwa,
increasing
składowiska odpadów powęglowych to jedna z palących się hałd niedawno jeszcze przy Mianowicach Śląskich, po kopalni się Mianowice, są zjawiskiem, czy są obiektami, z którymi spotykamy się bardzo często.
So these are the effects that we show you.
Mojej wiedzy znanych, zarejestrowanych w jakiś sposób jest około 200 składowisk odpadów.
So we had 200 of the post-mining deposits all over Poland. So I'm saying about all 3 basins.
Natomiast warto podkreślić, co jest bardzo istotne z punktu widzenia tematu,
What is very important, the fact that 20 of those coal heaps or the small heaps, they are thermally active. So monitoring of
prawnie istnieje obowiązek monitorowania różnego rodzaju składowisk odpadów. Niektóre nie są ewidencjonowane w taki sposób, z tym monitoringiem jest różnie, ale ze względu bezpieczeństwa warto z tego skorzystać. Dlaczego zdalny monitoring? Dlatego, że wiele, zwłaszcza tych najnowszych składowisk odpadów węglowych, mają bardzo duże objętości, mają bardzo duże powierzchnie, często trudno dostępne ze względu na przykład na nachylenie skał takich składowisk, a poza tym
so we have quite a lot of coal there in those heaps, in those deposits, means that there's possible to have the self-combustion or the self-incineration.
przepraszam, coś mi zginęło, pojedziemy. No i teraz już przechodząc do
And right now, going to this remote monitoring, what can we use today? First of all, the monitoring vision, thermovision as well, multispectral monitoring, and one can use the observation by the leaders. I'll tell you later on about it. And we can have some detectors of the points.
wbudowaniu w bryłę składowiska czy zwału czujników z możliwością transmisji danych pomiarowych i zdalnego odczytu. No i proszę Państwa,
So
czego oczekujemy od takich systemów?
what can we have? What can we expect? A high precision.
Łatwości obsługi, brak konfliktów z istniejącymi instalacjami.
And then we've got the institution around.
Warto powiedzieć, że składowisko, które miałem przyjemność kiedyś
So
składowisko hałda skalny
we had the Hałda Skalny close to Bolesław Śmiały.
biegną linie energetyczne.
There are some energy lines from the neighbor.
Istotne ograniczenie w możliwości stosowania dronów.
These are the drones.
No i łatwość interpretacji wyników.
And an easy interpretation of the results.
Wyprzedzę, powiem tylko tyle, że takie rzeczy
So those things, the remote monitoring, not always give us the possibility of meeting all those functions. And then we've got a vision monitoring. It seemed to us that it's not that important, but allows, with the repetitive actions, to see the morphological changes of the positions. For example, the slopes and the slides of then dissolution, also the erosion of the surface. It will allow us to see and notice the steam or smokes. So then that means there's a thermal activity. One can notice also the warnings of excessive vegetation. That would mean there's a thermal activity locally. It's a higher temperature supporting the vegetation. Sometimes the drying out and dying of the and winter we can have the melted snow. So it's quite a lot of spectrum, not using any other. And then the monitoring. We measure the radiation infrared of the deposit. So we measure the temperature. It seems to be a very good material. However, there's quite a lot of things like, for example, the sun radiation. If one part is with the solar radiation, we've got the different colors also. So also in the with the same wind, and this is all connected with the landfills of the self-heating. Well, then we have the gases or steams or vapors. This is a KOMAG building. So we've got the wall with the sun radiation, and then we've got we have the same northern wall with no snow. So we've got the different elements, building elements, and they can fracture and interfere. Measurement, then the vegetation, the same building. Look at the dark spots. These are the trees. This is just steaming from the trees. And it's completely different. So one has to be very careful with the use of the the use of observation in the infrared. This table is not that very interesting, but important because there is an element in the second line, in the first column, the isothermic. About 80 degrees, material starts to have the gases around, and it would mean that the temperature measured in the infrared is lower than here. This happens 10 centimeters below the level of the landfill. So I've got some sweating, also the hydrogen, methane, gases. So these are some interference with the coal spoil heaps or landfills. You need to take into account this element as well. Due to the fact that 20 years ago we had a chance to, with my team, to extinguish, because you can. In Władysław Śmiały, and we learned during the thermovision to have the reliable and comparable result. Should be done just before the sunrise, not too fast after rains. An important thing is we need to compare the pictures and the photographs and find out the differences. On the surface, the change with regards to the previous measurement, this comes from the fact that sometimes the fire is connected with the fall of the temperature by evaporation. Multispectral monitoring, a very good, excellent tool. There's a photograph also, and all the colors, all the lights, visual light, there's something we could see, but also the microwaves, infrared, ultraviolet. Many channels, very costly. And it depends, of course, on the channels. The cost depends on the channel, but this is being used wider and widely in the industrial vegetation or agricultural, but also the observations of the ocean's flora, also the trees in the woods. We also have such tools used to find out the pollution of the surfaces. I'm not sure, I'm not able to evaluate the use, especially that some time ago I said that you can have just infrared. Observation by LIDAR, light detection and ranging. LIDAR might be useful with the proper use of the scanning, or the scanner, for measurement of the deposits of coal. The geodetic measurement shows quite a bit of deviation of measurement, because they are not very regular forms. We do not know the density also, but by the LIDAR you can, and it's time consuming and work consuming. It could be scanned more efficiently and in a faster pace. And then also the remote recording or of the point of the detectors. It's got its, of course, the disadvantages as well. The problem with those solutions is the continuation of operation and the reliability of the system itself. Due to the fact that the physical properties of the materials are not homogeneous, then that would have to have a lot of detectors or sensors, because coal and the waste, the spores, they're quite good isolation and insulation properties. So if you want to check temperature unfortunately would have to have it. We'll have to build a lot of detectors and sensors. To sum up, for sure, the methodologies of the remote monitoring decrease the time consumers of the control of the heaps, of the spore heaps. But unfortunately, one cannot eliminate the in situ, so on site. If there is any change of temperature, for example, not necessarily increased, you need to go there and have a look at the probes, the samples, the air samples as well, measure the temperature. Always, independently, what are the rules or the principles? Well, I need to elaborate about the methodology of eliminating the impact of the fractions and so on. The drones can make it possible, but sometimes if one can't be used the objects of the civil masts, high buildings, and use the existing cameras, because most probably the solution will be less expensive, and the frequency of the measurements, so not too often. It's pointless then. For the changes, I would say that 1 month, intervals between 1 month, monthly intervals should be enough. Of course, coal heaps no, because coal deposits, of course, we've got much higher, it could be sooner, because we've got evaporation water, but the frequency of the spore heaps, post-mining heaps, monthly intervals should be, in my assessment, in my area, should be enough. Thank you very much for your attention. Important information, especially the monitoring methods, and its limitations. Do you have any questions from the room, from the audience? This time I'll ask, because you mentioned the use of the detectors directly in the landfill or the spore heap. Those detectors or sensors would be easier to recover for a longer use, because it's a living organism, a living object. Would be difficult. With a selection of any methodologies, we need to find out, and one thing must be found: the cost of the purchase, and then the cost of operation. The operational costs, that's all right, but we need to remember that each detector, each sensor by batteries, it's got a lifetime determined. So the measurement of temperature, and let's answer. about the result. So if we have all the time, I would be very right now, very careful and cautious with such solutions. Of course we can, but we have to weigh the cost, a lifetime, the benefit, and the cost against the cost. Thank you very much for the explanation and the answer. Thank you. And then we've got the condition of coal, hard coal, export, import situation. You'll have Mr. Waldemar Mijał from Łukasiewicz Institute of the Non-Ferrous. It's been a while. I'll present the example and the state or the condition of coal mining. I prepared it with the representative of the Central Mining Institute and the Professor Barbara Tora with AGH University. According to a report by the geologist, the total is 64 million tons. Then this is a steam coal, 70, coking coal, 27, and some other times 1.25%. So we've got three main basins. First of all, we've got the historical lower Silesia, and we do not have it operation there. It's 440 million tons. Then upper Silesia, quite a lot of mines, also the 51, more than 51 millions of tons, and then 12 millions, which is the biggest, and in the east of Poland. And we've got only one mine there, Lubelski Węgiel Bogdańka. For the so industrial and the general ones for 2019, it has not changed a lot because it's 300 tons, tons are small. The industrial ones, more or less the same level. In 2022, it was to 4 millions to 200 millions. Then we have in Lower Silesia, no change. So we could have the general increase by the finding out investigation of the Nowa Ruda mines. Then Upper Silesia. Right now the very same 64 million tons. Industrially, could less, from 4.7 billions to 4 billions to 300, 260, and then Lubelski coal here. We have the same, more or less. Oh, I think there's a mistake here, but no changes. For the main producers or the mining, so it's a JSW, Jastrzębska Spółka Węglowa, the biggest coking coal producer. Hard, so I've got 4, Borynia, Zafijówka, Budryk, Knurów, Szczygłowice and Pniówek. For Borynia, 30 million tons, from 35 to 5.2 produced. Then for Budryk, with 200 million tons, 34.2. Knurów, Szczygłowice, so with Knurów for 130 million tons, Szczygłowice 185. 34.2, 35.1 types of coal, and pniówek 54 million tons and 35.1. Then we also have in JSW also the sales of also the aggregates Budryk, Szczygłowice, Pniówek and Ruch Zofijówka, the aggregates being sold. Then we have Polish mining group, Polska Grupa Górnicza. We have 7 plants, the biggest producer of coal in Europe for the steam coal. So we've got Rov mine, so it's 223 tons. Chwałowice, Jankowice, Marcelowy from 31 to 34.2. Then Kawuka Ruda, Bielszowice, Halemba mines. Couldn't find the type and also, but mainly PGG is a steam coal. So mainly the steam coals. And then it's Piast Ziemowit with a 255.7 million tons, just for Ziemowit mine. Nowogór Bolesław Śmiały, Sośnica, Staszic, Sowice Wesoła. Then we're having Południowy Koncern Węglowy, Southern Coal Concern. We've got 3 mines there, Brzeszcze, Janina Sobieski. For the coal production, we also have the sales of the aggregate, mainly from Janina Sobieski. Additionally, we've got Lubeckie Bogdanka, which is one of the leaders, hard coal producer, manufacturer. Mainly, it goes to the electricity generators. 31, 33 are there. Then we've got Węglokoks, which is the only in Bytom with KBH Bobrek. It's 16.5 million tons. This Biechowice Bobrek. Then we have Silesia. Mainly for energy sector, so it's a steam coal from 2012 and it's more than 500 million tons. According to PG Silesia. Then we've got 2 small private companies. The first one is the Siltec that operates the old Strowski mine. Then Janina, and it's in Poland from 2002, and it was just the first private mine. It's mainly sales to the domestic market. Then we've got Eco Plus, the old Powstańców Śląskich mine. Main coal is 32.1, the steam coal. So that's the production. It drops drastically from 61 tons to in 2019 and 2023 we've got less than 48.5 million tons. So it's quite a drop and a regress. For import, we imported 15 million tons of coal. For 2023, this is the decrease to 10 million for last year. For the steam coal, it was more than 12.7 million tons. At the end of 2023, it was 8.2 million. And for the coking coal, from 2.2 to 1,900,000 at the end. So the import and export. For the imported coal, for the steam coal, this is the last year, 2022, the end of 2022. Import by the report. This is Botswana, Canada, India, mainly Russia, then Kazakhstan, Ukraine, Czech Republic. So it's a coking code for the export, mainly it's Scandinavia and Germany. Also Czech, Ukraine, 1.3 million tons of the energy and 3.4 million tons of the coking coal. Then mechanical processing. In JSW we've got 6 processing plants, 6 in 1 in PGG 13, in PKW 3, Lubelskiego Gdańska 1, Węglokoks 1, Silesia 1, Siltech, also the sorting plant, and Ecoplus. According to it's not an nomenclature, it's enrichment of the dry processing, and they've got the dry washer, and they could operate with the sorting, or it's just the sorting plant. For all these processing plants, for enriched or processed coal, got 26 coal processing plants, around 20 plus 20 millimeters, 22 plus 0.5 millimeters, 8 for everything, and just sorting, as I said, is 1. So, so the classification, we've got the screens, the vibration screens, WK, or the grid like the Suski. Then we've got the crushers, mainly jaw trackers like the KWK, and Bradford crushers for a selective crusher in JSW, for example. Then we've got the washers. So we just have the ones for sludges and one for the grains, but we can say also have the enrichment for the assortments for, and that's why we've got DISA, which is used for the assortment above 10 millimeters. Then for, I said this is one place in Poland that has the dry type, the wind type, and we've got the optical sorters, and for the separation in water, usually this is the DISA or group oil, or we've got just the deposits. And we also have the best DISA, ORAS, and some different, all the depositors of the deposit ponds below 2 millimeters, where there are the stream enrichers, and for flotations, we've got float times, JZ or Almineral. So this was just a short review. It was in 2019, so we wanted to remind you what was the difference right now with the authors. Thank you very much for an update information. Questions? Then let's go to the next one. Mr. Waldemar stays here. We've got the ores of zinc and lead in Poland. Together with our colleagues, we prepared a very short review of the zinc and the balancing. When 91 million tons of for metallic zinc, it's 3.9 million of tons. And then also the lead, 1.5 million tons. Mainly we've got the zawiercie. So we've got two perspective ways, zawiercie, Gołuchowice. Unfortunately, we've got some oppositions and the social protests or the social disputes. They haven't started even the operation. We don't know if it's going to be successful. They've got Olkusz, Laski deposit or seam. They finish in 2022, 2020. However, it's one perspective is and 11, and then 35 million tons of zinc and lead. Then we have Bytom, historically, two deposits there, and two seams. Dąbrówka Wielka, we can see that on the left side, and Chrzanów, historically, and it's not operated for a long time. Then we can see the ores of the elaborated of the State Geological Institute of the last report was 2022. For 2018, it was an increase from 83 to 92 million tons. So there's a more detailed investigation of Laski deposit. So very often for the zinc the same. For the lead, metallic lead, so it's the same actually, around 1.5, 144 average of million tons. With regards to industrial deposits, since 2016 till the end of, we'll have the industrial deposits shrinking. So we did not have any operation during the economically from the primary deposit. So that's why until 2020 the operation has been finished and the industrial deposits for this is around 0. Not all of you are connected with the processing of the ores. So our main minerals that are for us for processing, these are sphalerite, main zinc mineral, zinc, and then galena for lead. Could be enriched gravitationally, flotationally, by floating, flotation, or depositing, or flocculation. So they were used in Pomorzany mine. Then we'll have also the oxygens. So we've got the oxides. But we stopped in the 90s to explore those deposits, and those concentrates are not being mined. It's smithsonite and cerusit. Smithsonite in the left, on right with cerusit. Then marcasite was for the sulfuric acid. Right now for flotation of for us it's rather a spoil rock. It's a dolomite then. For the mining, For the zinc and lead, it's the GH Bolesław. So at Olkusz Pomorzany, but it's being in decommissioned from the 1st of January 2021. Then we had the mechanical processing. We had the primary. Right now we've got the secondary slums or sludges with the electrolytes. We've got also the metal Bolesław, the furnace. Mainly the imported, and also the zinc, Gravin Montenegro, where ZGH Bolesław is at 99 shares for the zinc and lead. We also have the miasteczko Śląskie with a 92% of the shares, and it's mainly from the imported concentrates, but also we've got a daughter company, Baltech. They've got the dolomite aggregates, and the zinc and polyuterine. Also we've got the processing plant for flotation products. And since 2016, this technology is functioning. So right now onto Azerbaijanic, and as you can see in red, we finished the operation, the mining of the primary. Then this spoil for the zinc and lead could be potential of the concentrates that can go to the furnace, to the metalworks. Bytom, Bolesław and Chrzanów. We've got the deposits of post-flotations, and we've got 100 million tons. So for the place in Bytom, we can say there's 3 areas. So this is Orzeł Biały first, Nowy Dwór and Marchlewski mine, and the total resource is 19 million tons. So it's 2.7% of zinc and 0.62, very similar to the ore. Delewkos Bolesław, Olkusz Pomorzany. So one could say there is 50 million ton, and Chrzanów, Trzebionka, of around 30 million tons. For the concentration in those 2 areas is 1.1, 1.3, 0.9 for Chrzanów, 0.65 for Bolesław, and 0.5 for Chrzanów. In total, it's 99 million, 1.6 and 0.6 of lead. The minerals are mainly quite a lot of sulfides there, from 40 to 60% of oxidation. For lead, from 70 to 90%. In case of sulfides, and for Bytom, it's the level of 3.1%. In Olkusz 1.6, 1.7 in Chrzanów, and then the remaining parts are the minerals not useful. The sulfides, limonites, dolomite, calcite, silica, clays, and gypsum. The concentration right now is in 2 locations. We've got the processing plant of the end, the concentrate with silver, na Olkusz Pomorzany.
Przerób odpadów rotacyjnych. Powierzchnia składowiska, która znajduje się w niedalekim sąsiedztwie dawnej kopalni Olkusz Pomorzany, to jest około 40.
So it's 110 hectares.
Deponowanych odpadów to jest około 42 miliony
It's
ton.
42 million tons.
I jak widać na załączonej grafice, skład chemiczny to jest około 1,2-1,1% cynku, jeżeli chodzi o całkowitą zawartość. Jeżeli chodzi o ołów, to jest
So this for zinc.
w przedziale 0,8 do 1%, w zależności oczywiście od rejonu
It's
deponowania
up to depositing.
na stawie, gdyż jak wszyscy wiemy, nie
As you know,
ten materiał
not always and not everywhere.
rozłożony, a po prawej stronie widać na górnym prawym rogu staw numer 4, który jest najczynniej obecnie prowadzona jest z niego eksploatacja, nadawy do zakładu przeróbki odpadów rotacyjnych, a na zdjęciu po prawej stronie na dole
And on the left side we have the flotation construction of Yemen.
I tutaj uproszczony, że tak powiem, schemat przeróbki odpadów rotacyjnych. Głównie składa się z flotacji tylko do mielania nadawy, średnia zawartość.
So just for the feed of zinc and lead, it's 1.4%, 49% lead, more than 8, and 6% of. And we've got a patent of from 2019. As you can see, it's 1.2%, it's 1.2 here. It's up to 40% for.
I należy nadmienić, że na to rozwiązanie uzyskaliśmy patent o numerze 227047. Jeżeli chodzi o kolejne rozwiązanie, gdzie tutaj
Then the concentrate of the silver.
jest demonstracja w warunkach operacyjnych, to jest oczywiście projekt, na bazie którego powstała ta instalacja, to jest demonstracja w warunkach operacyjnych innowacyjnego procesu
Innovative creation of the concentration flotation of the zinc lead with increased level of silver. So we've got the lye.
odpadów wydobywczych po przeróbce cynku i ołowiu. I to była praca realizowana
So it was a work
programu sektorowego innowacyjny recykling w ramach
with the innovative recycling 1.2.
jeżeli chodzi o koncentrat,
For this concentrate, we're
koncentrat zawierający ponad 40% cynku, jeżeli chodzi o koncentrat o podwyższonej zawartości srebra, niskiej zawartości ołowiu między 1,9 a 2,3%, żelaza od 5 do
firm iron,
4%, ale podwyższonej zawartości
but increased level of silver, of course, but it depends on the feed that we're having.
po procesie tej elektrolizy. Ale to jest oczywiście zawartość srebra w PIM. Takie główne 4 wnioski
So 4 conclusions, but the perspective area
eksploatacji rud cynkowo-węglowej z rejonów w Polsce ze złóżkiem
in Poland would be from the primary Zawiercie. We've got 2 deposits there,
ze względu na ten sprzeciw społeczny,
but this is a social opposition there.
zaniechane.
So they stopped the works.
Oczywiście obecnie funkcjonowanie przeróbki mechanicznej
So functioning of the zinc and lead, this is mainly the flotation and the silver. And operation time for the flotation started in 2016. This is 25 years and depends on the materials. And is very often depending on the capital, ZGH Bolesław. Mainly the price. Thank you very much for your attention.
Moim zdaniem interesującej prezentacji dotyczącej obszaru lub cynku i ołowiu. Ciekawszej o tyle, że tematyka rzadko dosyć gości na naszych konferencjach. Może dlatego też, że rzeczywiście eksploatacja od kilku lat już nie jest prowadzona. No może coś się w tym kierunku zmieni po tych informacjach, które Pan przedstawił. zobaczymy, jak to będziemy przypuścić. Czy są jakieś pytania? Mam takie pytanie, bo
I have a question here,
my też w KGHM
because in KGHM we've got a flotation, spores and waste.
do ustawy o odpadach, na odpady to 4 biegi.
And with regards to the waste processed are not the waste. So you pay for the.
Udało wam się obejść te
How did you make it?
rozwiązane, bo u nas to jest trochę ze względu na dolnośląskie wdosie problematyka ta wynika, że oni będą według nich
According to the classification would be changed if we are processed. We'll have to pay for the deposit for the depositing. In this case, did you have any problems? And if yes, how did you solve them?
Jeżeli chodzi o opakowania środowiskowe, to tutaj powiem, że nie wiem, bo głównie opracowywaliśmy technologię. Jeżeli chodzi o opakowania środowiskowe, to najprędzej odpowiedziałby albo nasz zakład ochrony środowiska.
So we'll have the environmental, most probably, or the QBS, they would know, because they implemented it. They know exactly cost were burdened, and they met. My name is Kajtan Witecki, and I'm the manager of the processing plant in Kuprum, KGHM. We prepared together with my colleagues, Mrs. Anna Kupcevich, the presentation of the critical elements. I would like to present the outline about KGHM. What are the conditions and how, what do you have the knowledge for today? So it's connected with the European Act about the critical. So what is the critical element? It's defined as the material for the EU, and it's also connected with its availability. So it's first of the risk of supplies and how important it is. So it has to have the meaning and so first of all, the very first critical element was in 2011. So that is why most probably the critical element is adequate to the situation. until 2040 for the product that is necessary, its usage will be used 42 times. This is the world, not for Europe, but we can see the tendency, the trend. So the critical elements are important in the chain value. There are energy sources and materials important for the space, defense system, and industry, climate. We also should be allow us to a strengthen of elements of the European values, and then the monitoring of the risk. Ona będzie miała So I've got 33. Za chwilkę, no. So we'll have 3 sub symbols. So they're the rare earth or also the limes. It's quite a lot of them, as you can see. What did we do in KGHM? So we started with the ore that go to the processing plants and the iron bridge, żelazny most. And then this is the system that we wanted to know exactly. And the materials and materials which are the wastes. We focused also on the analysis of the objects of Wartowice, which is an object close to cold copper. So we can think about some recovery of the elements of the use of the feed. And also Gilov, but it's not, we don't have any reclamation. So that is why it could be used. So in blue, we've got all the elements that are right now being recovered. In red, we've got the ones that are critical ones. As you can see, there is copper and nickel that could be used in this. So these are the quarks. What we have in, if we can see this element is concentrated in our ore. So this is what we have right now. As you can see, I presented the above 1, so more than average. we presented the very same table, but it's the flotation waste, and the concentration, as you can see, is much lower than in the ore, so that would mean that they go to the concentrate and they are concentrated there with copper and silver. Now I modified the table and I presented here the ones where I reached more than one. But those values of the elements that we can see, they are low enough that the recovery of the for the flotation cannot be implemented. In the future, you can say about the copper, and if the technologies will be there for silver and for copper only. The next stage, the concentrate of copper, because whatever was not concentrated, most of it went to lead. It went to the furnace there. And we then defined in which places and up to what extent they are concentrated. So I've got a table here, a collective table, presenting the maximum values in the way, mainly in the waste, for the concentration of those. So there's quite a lot of cobalt. So I will not show you where is it. Zinc as well, or we can think about the recovery of those elements, even with the assumption that we'll add additional elements. Like the pyrolysis or something, and then Głogów, this is what we made for Głogów 2. As you can see, the cobalt here is, and one of the product is highest, much higher than, and the same for nickel, zinc. There's a potential for recovery of this. Zinc was not part as the critical element, but it's quite critical for those hydro, but we could use the hydrometallurgical methods for recovery of the rare earth critical elements. Or the ones for this technology was here from the, but also from the refinery of lead. So that is why frankly speaking, the knowledge about the elements, the critical elements, is known. We know where are they. We know where they are. The problem is with the technology, as long as properly this technology it's not efficient enough. But I would like to encourage you to cooperation, because the know-how is there, and we have Thank you for your attention. Thanks for presentation, or for this presentation. For the critical elements, not only critical, but also the ones that are very important.
Doczytałem, że jesteście jako KGHM jedynym dostawcą pierwiastku Niemiec w postaci nano albo coś takiego. To jest ilości kilkanaście ton rocznie. Tak,
Dajmy to tutaj. So for flotation of our, the goal of our actions was to see the effectiveness, the efficiency of those for flotation. And the flotation process of our Polish ores of copper is the verification of semi-technical scale. So we've got nano and micro particles from birch and also pine. So it's Bolkowice mine. So it's a carrier of the organic coal TOC. So that's why we wanted to have this organic carbon, organic coal, and the material was taken in a proper way just to make it representative. So the very first we had by the lab in KGHM Kuprum by Mr. Kajetan Grycki. So the possibilities of what's being used right now, mainly used for flotation in KGHM Polska Miedź.
W tych badaniach został zastosowany odczynnik występujących z antogeniami w 100% w postaci brzozy i świerku nano i mikro w różnych wariantach oraz jako miks xantogenianów i tych badanych odczynników w różnych właśnie dawkach 20, 30 i 40%.
So 20-30%.
Badania wykazały jednak, że
So the results presented independently on the use of a mix with different dosing, we have not had a better improvement of the quality or the yield as well. We also had the second direction here, the colleagues from KGHM Kuprum, and it was checking of the possibilities of the so this was also nickel and so one was
Kolejnym etapem badań był już badany u nas w Centrum Przeróbki Surowców Mineralnych, czyli nie będę mówił tutaj, jak przygotowaliśmy materiał, natomiast chcę powiedzieć, że w naszym centrum jesteśmy w stanie...
So in our center we are ready to prepare the full scope of such a preparation of the materials for flotations,
przyrządy do analiz składu ziarnego od kilku mikronów, urządzenia do kruszenia w różnych wydajnościach,
the crushers of different,
a następnie również
and also
młyny
the mills,
laboratoryjnych do przygotowania środowiska laboratoryjnego, również technicznej,
also the semi-technical with the efficiency up to,
jak również maszyny flotacyjne o
and the flotation of different,
u nas wykonać wzbogacania grawitacyjne, magnetyczne i
we've got processing, electrostatic and all types of.
Tak wygląda kontynuacja badań w skali laboratoryjnej. W tym przypadku dążyliśmy do wytworzenia koncentratu końcowego poprzez flotacje główne i kilkuetapowe czyszczenie. Flotację rozdzielającą.
So I've got the flotation there and
Prowadziliśmy przy dodaniu dwóch rodzajów czynników
with two parts.
nano, świerk, mikro w różnych dawkach. I takie mamy wyniki.
So these are the results
Tych koncentratów otrzymaliśmy
for flotation, and then
dwa produkty, pianowy i komorowy o zróżnicowanych zawartościach miedzi i węgla organicznego. Widać tu wyraźną selektywność.
so we can see there's a selectiveness, certain selectiveness.
Znaczną zawartość miedzi przy depresji węgla organicznego, natomiast komorowy odwrotnie niską zawartość miedzi
So it's a very low
i
contents of
wysoką zawartość
copper.
węgla organicznego. To było w przypadku brzozy nano. Nieco gorsze wyniki otrzymaliśmy przy zastosowaniu świerku mikro.
So it's a little bit better, but you can see also that
Selektywność oddziału węgiel organiczny miedź. Mając już te wyniki, mogliśmy przejść
knowing this exactly, we know exactly what are the
testowaliśmy naszą instalację pilotową. Do testów ciągłych instalacja ta potrafi przerobić około 80 kg materiału na godzinę. Potrafimy zmieniać schemat technologiczny zależnie od naszych
So it depends on our needs. We've got the flotation here up to 400 to 10, 40 liters. It's a pumping material, so that's why we can change this and it's then adjusted with automatic system of control and of parameters operation. Does not mean they can operate all the time, but with a certain proper it can operate quite automatically. We can add also the mailing of the semi-products and classification as well. And we made 2 tests there. First test was a standard test with a standard indicator with and then the next one was a nano birch to the mix. So we made this test just to check the lab. As you can see, the concentrate was not any better. And also the concentrate, and we had the yield a little better. The second with lining, it was the concentrate, the end concentrate in the kilograms, and then additional flotation, also in a continuous way, in 10 liters. Then we added also the lignin in different doses. And in this case, it's not a copy, but practically very, very similar results. So we can see a selection of different characteristics. Very similar results for the same reagents, so the optimum dose should be verified in the industrial conditions. The nitropine, it's a little bit worse because there's more organic coal. Summarizing, during our studies and researches that we made on the reagent of the lignin, we will not want any properties of gathering or concentrations, but we could have 2 products with a very verified COCR that could be for 2 different hydrometallurgical levels, so the suspension and shaft. And the 2 additional pluses are the use of segregation flotation with the reagent might be the alternative for the high temperature treatment before the metallurgical process. And the economical aspects of decrease of the coking coal added to the processes. In this case, this is a shaft process. Thank you very much. Thanks a lot for a very interesting presentation. I wanted to ask if you have any questions. There is one. I've got a very basic question because generally, so most probably the pine or the birch would be the same. Have you checked the verific absorptions when they are gathered?
To znaczy, jak się zachowują wobec ziarna mineralnego,
So this reagent for the lignin, it's like the foamer, so they can improve a little bit. We don't need too much different chemicals, so it could be controlled, the addition, if we use it. Any other questions? In this case, that was the last presentation for today. I would like to invite you to dinner in a pub, and tomorrow we start 9:30, the last session.